everyone, my name is Jasmine. I work at Synchry as a front-end developer. It's so good to see everyone here. Welcome to the second day of conference. So my first question for you all is, how many people here have heard of Synchrony? Oh wow, that's actually more than I expected. I didn't know what Synchrony was until last year, but Synchrony provides the financial layer behind a lot of clients like Amazon, Walmart, Lowe's, Sam's Club. And the challenge behind this was, how do we scale and maintain consistency across all the UI for all these different clients and different products and different services that we're offering. And so this is where the idea of a component library came in and the answer to our challenge. So first off, what is a component library? Every user interface that you see is made up of components. You can look at each field as Lego blocks that, when coming together, makes up a form field. So the text field with a button, additional form text fields all come together and make that form field the Lego blocks that are the building pieces of the interface or application that you see. Why do component libraries matter? One, for UI consistency, to ensure that the design is uniform across all the different products that you have, like I mentioned earlier, to reduce technical debt. When you have one singular place that the component is defined, designed, and developed, you can reduce technical debt and not have one team be working on, let's say, the credit card form, and another team be working on the same credit card form but for a different client, and the UI is not consistent, developed differently with different solid principles. That causes technical debt later on for whoever onboards into the company. And I'm sorry, my boyfriend is staring at me, smiling. He's not in tech, but he's here to support me, and it means a lot. And 3, for scalable growth, again, as we continue, the company hopefully continues to grow and we build more products, we want everything as seamless as possible. So I'm here to talk about the blueprint that we have found successful for architecting a scalable, maintainable component library. So first, we're going to talk about the foundation principles, understanding this philosophy that Kent C. Dodds came up with. This is a React philosophy for compound components, where we we compose over configuration. So we try to make the building blocks and not have one singular component be configured to do like 10 different things. We want each component to do one thing and one thing really well. 2, the building blocks. When we're building an application or a product, it can be a lot. And so we want to start with atomic components and start with small components that build up into that bigger component, like I was mentioning earlier, with building a button component, a text field component that ends up making the form field component. And this is just a small example, but if you look at the devices that you use and the apps that you use, you can see like how complex things can really get. And 3, I'll talk about our implementation, the tools and patterns and best practices that we have found useful. And yeah, so let's get into it. Now, the problem with the configuration is that it can get very complex. You can have one component with 10, 20, 30 props. In our case, when we initially had our component library, it was ad hoc and just a bunch of developers throwing together components not really being maintained. And so if we needed, let's say one company needs this functionality, we would just add a prop that could do that functionality instead of taking the time to build thoughtful components. And so this is why we choose to use composition over configuration, so that when each use case requires new configuration, your component doesn't become a liability, doesn't become a liability instead of an asset. Sorry, got that mixed up. So again, just want to emphasize the core philosophy of composition over configuration. We're building the building blocks so that developers can use and build their components on their separate product teams, building out whatever it may be that they need. We just want to deliver the pieces for them and avoid using brittle props that lead to tech debt later on. That, again, just becomes very heavy. If things change, it's already in the code base, and once it's in the code base, as a new developer, you don't really go and touch it and change it and fix it. You just do what the new requirements want you to do, right? And so we want to promote clarity. We want usability, code clarity, and easier testing workflows. Here is an example of configuration versus composition. So you'll see the button component. Here we have, I think, like 8 props that are all doing different things, and there's no way to know like where each prop is being applied. Like we have icon check, but then we have to add another prop to position it to the left. Whereas if you look on the composition approach, you have your button and you have your button dot icon, and you can move this around. You can move the icon before button dot text or after button dot text to position it either on the left side or the right side. You don't need to define that as a prop. Does anyone have any questions so far? Perfect. So as I mentioned, we're going to start with the foundation. This is a design principle by Brad Frost, if you've ever heard of him. He has broken down the foundation for building a successful design system into atoms, molecules, organisms, templates. You can call them whatever you would like, but this is the template that a lot of companies follow, and our company follows as well. So you have your smaller components like the buttons, the inputs, typography, which make up the search box, the form field, the card headers, and you use these and add to organisms to make a navigation bar, product list, an article. And again, like it gets even more complex when you start to build out templates, page layouts, grid systems, and containers. So some key success factors that have been really helpful for us is discoverability, living documentation, and automated workflows, which I'm going to discuss in the next slide. I'll come back to that. So compound components, if you remember the example from before, you have a parent component that manages the shared state for child components. With the button example, you had the button root is the parent component, and then the button dot icon is the child component. And again, you want each component to have one thing that they do well, and control their own behavior. Rendering props and sharing that complex logic, we can use state or context to share the context between each component. And then we want to separate each component with their UI concerns for business logic, testability, reusability, and code organization. So again, here is another example of the compound components in action. On the left, you have the traditional approach, which I'll be honest, when I first started coding, this is exactly how my components looked. I would have one component and I would have a prop for the options, for countries, a placeholder, a prop for choosing a country, searchable, and you're just continuing to add on all of these props to make it configurable to your needs. Whereas when you go with the compound component philosophy, you have your parent component, which is the select, and the select will handle the functionality of when you click on the select button and it drops down, it handles that one singular functionality. You have your trigger, which handles that one functionality, and select.value is just what is displayed in your trigger, that placeholder, that one prop, and then select.content. Content does one thing, search does one thing, and again, like everything has one thing that it does really well. These are the tools that we have found useful to empower this philosophy. Has anybody heard of Radix before? Or it might be Radix, not sure how to say it, but awesome. Yeah, so Radix has accessibility built in, which makes it really great for a building block on top of your own components. They provide very unstyled, accessible components that you can then style yourself, but have the accessibility built in so that you're not having to worry about that. Obviously, you should still worry about accessibility, not what I'm saying, but it provides that foundation for you. And then we use Tailwind. You don't have to use Tailwind. A lot of people like it. A lot of people don't like it. It's personal preference. I will say that with Tailwind and using the Tailwind config, we have a design system that gives, basically a design system will give you tokens, and that's like their terminology. The tokens are just JSON variables that you can input into your Tailwind config, and it makes it really easy to have different themes. So we have different clients, like Walmart has a different UI, Sam's Club has a different UI, Verizon. We can just have their design brand and tokens in one theme and toggle back and forth using Tailwind. So it has been very powerful for us. Storybook is how many people have heard of Storybook? I think it's a little more popular. Awesome. I really like Storybook and its latest improvements that they've made, because now accessibility testing is baked in. You can have component testing baked in, and it's all in this really nice UI interface. And another thing that is really great about Storybook is that your product team or your designers or your managers can go in and look at, sorry. As I was saying, your product team or managers can go in and look at these components that you've built and do all the testing in there. Like, you don't need to wait to put it in a dev environment and bring that dev environment to those teams, or put it into production even and start testing from there. You can test all inside of Storybook, and so it just makes really great for sharing across all different teams. And it's also really great for documentation, because your component already lives in Storybook. You can have the documentation pulled up next to your component so developers can easily understand what your component does, how the props work. They can even play with the props and toggle them on or off. And what we have found really helpful is that you can use MDX docs inside of Storybook. So we have a local showcase that local environment where we build and test out our components before we put them onto Storybook. And they're all just React components at the end of the day. And what you can do, since MDX can hold React components, we'll just import these components into an MDX file that displays into Storybook. And so, yeah, if we have time after, I can show you. And then lastly, YALP. So how it works at Synchry is everything is a micro front end. Everything is a micro front end. So let's think about when you go in to pay your credit card bill and you see the make a payment modal. That is a micro front end at Synchry. And so with that, it kind of makes things a little hard to test components because everything is a micro front end. But with using YALP, we're able to test locally and have YALP basically import the component into our MFE locally, do all the testing, make all the updates, and it's going to show directly in the dev environment for that micro front end. So that's been a very powerful, useful tool for us. And again, just common our pitfalls to avoid and lessons that we've learned. The composition over configuration, having one component do one thing really well, and providing a better developer experience so that these developers actually use our components with good documentation in Storybook with clear examples. And just some like final warning signs. If you see these in your component library, these are red flags. Components that have more than 10 props, nested ternary operators, developers avoiding using your components, breaking changes in minor versions, this is not good, and the same functionality being implemented multiple ways. So again, the takeaway, composition over configuration, and if you can, get your company to invest in having a component library that is being maintained. That makes a big difference. And just treating your component as a product that's, you know, your users are your developers and you want to build for them and gain feedback with each version that you put out and continuously improve on. And then again, start small and continue to build your way up as Lego blocks. So thank you, everyone. It's been a pleasure. Are there any questions? If not, I can do like a quick showcase of Storybook. Oh. Do you mean with the philosophy of the composition? Yeah, so actually, as I said before, our component library has been ad hoc, and so it's been a bunch of developers building out components and just throwing it into this component library. And now that we are pushing for this composition philosophy, it's a lot different. They're going to have to spend some time to rework the code because we're now going from those 20 props to now having to build out components with subcomponents. We are getting pushback, but when we're able to demonstrate in the documentation the flexibility that it offers, where they now have the power in their hands to build out these components using the subcomponents, as long as like you're able to express that, I don't think we've had any further pushback other than the initial, yeah. Anyone? Oh. Yeah, that's a great question that I actually didn't cover. So like how are we handling the migration, the rollout of the newer components when all these components have already been built? Like why do this? um, and the reason for doing it is when I mentioned before with technical debt, like that is becoming a big problem in the component library and across other teams with inconsistent designs with product. Now we're working directly with the design system team to make sure that all the components, when they're ready, will match and meet those requirements, and providing a rollout phase so we're not forcing everyone to upgrade all at the same time, because they are broken down into such small pieces. It makes it easier for them to go and rework it because they can add a little at a time. And then having really good docs. I'm a really big believer of having good docs. Having that migration guide of a one-to-one, like this is how you migrate, was really helpful. Okay. Mhm. 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 Yeah. So, or yesterday I heard a really good talk about how you get how you make change happen, because change is not easy. There's a lot that goes into it when you do have to change, especially something so big like this. And for us, like going directly to the higher ups and the stakeholders and being able to present maybe a working prototype of how it could benefit the company. And really, when you believe in your vision, I think you can make others believe in your vision too. But it does take having the research, and you have to give them something that they can see and believe. So hopefully that answers your question. Mhm. Right. How do I make sure that other developers are following the design patterns that we are following? Is that, or Mm-hmm. Right. Okay. Um, Personally, we're out of time, so I'll answer your question out in the hallway. Thank you, everyone, for coming again.
fact or whatever, or like a statement, and then if you have done it before, you put your finger down. Sounds good? Yeah. All right. So put your hands up. You ready? Okay. Never have I ever opted to ask AI for an answer rather than use Google. I put my finger down. I do that. Okay. Oh, I see people. Wow, good job. Never have I ever copied and pasted a random code snippet, didn't know what it did, and put it in my code base. I did that before AI. Like, that was me on Stack Overflow. So you guys can put your hands down now. The game's over. Thanks for participating. But now that I got a chance to know you, just going to quickly explain who I am. My name's Rizal. I'm a tech lead of open source developer relations at Block. Other things that are random about me, like I'm a new mom, and I also created a community. Yeah. I created a community called BlackRel for like Black developer relations. So if you're in developer relations and Black and want to be in it, let me know. But it's be popping in there. And then this is just like, I was trying to figure out like what can I show you guys to show like my personality, and this is like this is Rizal Core. I'm basically on maternity leave, building random things that nobody ever this was me on maternity leave, building things that nobody ever really wants. Like, who will want a UI that interacts with your emotions or reacts to it? But that's just me. But anyways, back to the confession you guys made about basically using AI over traditional search. You're actually not alone. There's a lot of studies, and one recent study I found said that 55% of developers now prefer AI over traditional search in the US. But in the UK, it's even higher. It's about 62%. And with this in mind, many have predicted that AI agents are going to become our main interface. For example, at the Qualcomm conference called Snapdragon Insiders, one of the speakers was kind of like had on the screen like AI is the new UI. And then I don't know if you all are familiar with Rachel Neighbors. I'm a big fan of their work. They have a keynote where they predict the potential debt of the browser. And they're basically saying that instead of optimizing for Google search, we'll also have to optimize for AI tools and LLMs. Now, I do think that's cool, but I also take a look at these like agentic interfaces for a second, right? It's all just black and white chat. Every AI tool looks the same. And then, okay, yeah, sometimes you have like the AI agent that's a terminal. And to me, I love AI agents, but if this becomes our main interface, I feel like that's kind of sad. Like, just black and white, plain text, like, boo. I don't know if y'all remember back in the day, yeah, right? The internet was really fun when I was young. Like, I was like sneaking out of my room to go play on IMVU. I don't know if you guys know that, like make my avatar and everything. I thought I was talking to kids. Looking back, they were probably grown adults. But I would be on all of these random sites, everythinggirl.com, Millsberry, MySpace, of course making my layouts, and like the internet was just like colorful and loud and messy. And I'm thinking, if agents become our primary interface, we might lose that joy and interactivity of the internet, and like our kids won't even get to really experience that. Like, what is their life? Just gonna be on YouTube and then like typing into ChatGPT? That kind of sucks. But here's where I wanna bring some hope back into the room. There's this new technology called MCP UI, which adds like a UI interactive component on top of MCP. But I'm gonna quickly just go over what MCP is for folks if they're like, I'm not really familiar with MCP at all. Wait, also, has anybody here heard of MCP UI or used it? Nobody? Okay, a few people. Okay, cool, I'm actually teaching you guys something new. Perfect. All right, so for MCP itself, that stands for Model Context Protocol. And okay, there is the argument of people saying like, oh, that's just an API. I respectfully disagree, I guess. I think it's a little bit more than an API. In fact, it's a protocol, right? So think of things like HTTP and FTP. MCP is basically a shared agreement that lets all AI agents or AI agents that like adhere to that protocol speak the same language and be able to communicate with your everyday applications. It really brings like a standardization, so for each AI agent, you're not like creating a new custom integration. And you might be like, okay, maybe you've heard people say that, or you're like, so what? Listen, I've experienced using an AI agent pre-MCP, and it was like a little bit annoying. So I work at Block. Block is the company that made like Cash App and Tidal and Afterpay and Square, but we also internally made an AI agent called Goose. And we were using this internally because our teams all functionalized, and so you guys might not know what functionalize is. But basically, we were all in these separate engineering teams, like Cash App had his own engineering team, and Square and Tidal. And then our company was like, you know what, let's just put them all under one, and that created a lot of friction for us. We were like, I do things this way, one engineering team does things another way. So one engineer is like, I'm gonna make an AI agent to kind of automate a lot of these workflows for us. And it was cool, it was awesome, except when we wanted to actually integrate it into things like Jira or GitHub or HubSpot, we had to like make these custom solutions. It was really annoying. You had to know Python because that's the only way you could integrate it. And it kind of took away the fact that like this is automating everything, because it kind of stopped us in our tracks. So our team at Block was like, yo, what if we like had like some kind of standard? So we went over to our pals at Anthropic, and we were like, yo, we want to like have a standard or something like that for AI agents, and they were like, bet, we're actually already working on that. We were like, oh, great. So we got to like contribute to work they already had in progress. And then just the components of what MCP or Model Context Protocol is, before I like dive into MCP UI, you have the MCP client, and that is your AI agent. That could be Cursor, that could be Claude Code, that could be VS Code, or Goose, which is what my company made, and it's essentially where you're typing in your natural language request. And then you have the MCP server, and that's what's connecting your MCP client to those external applications. Perhaps it's like Playwright or Blender or Chrome developer tools, and within each MCP server, there's different like tools or functions. So let's say you wanted to connect your MCP, or you had a Google Drive MCP server, the different tools and function it might have is like create your document or leave a comment on a document, and so on and so forth. And then another thing that MCP servers do, I don't know, oh, you guys can see that pretty well, I think. I was gonna say I don't know how well you can see it, but I'll zoom in just a bit more, is they advertise their tools to the LLM so that the LLM knows, like, oh, this is what Rizal wants. If I said, hey, I wanna know what is on my to-do list, the LLM that's connected within the MCP client is gonna look at this description list or this advertisement and be like, okay, she wants to know what's on her list. She probably doesn't want to do the add a new to-do item. I'll probably pick the show all to-do items tool. And then the other part of it, of course, is the ability to just execute those tool calls. All right, so our flow for MCP servers, before I go into the MCP UI part, is you have the user, they make a prompt in the MCP client. The MCP client's like, oh no, I have no clue what to do, and it talks with the LLM creates an entire plan for everything, and then it connects to, or it chooses the MCP server and tools it needs to use. It does all the execution behind the scenes and returns that back to the user. All right, so I'm gonna do a quick demo of the MCP working. I'm gonna use the Chrome Developer Tools MCP server. This may be slow on this Wi-Fi. I was trying it, it was a little bit slow, but that's okay. So I'm gonna open up Goose and Command F1. You guys are gonna see my notes, but that's okay. All right, so we have Goose here, and I'm gonna tell Goose to, I already have the Chrome Developer Tools extension enabled, right? Or in Goose's ecosystem, we call MCP servers extensions because they extend the capability of Goose. So I already have that enabled, and I'm gonna tell Goose to use the Chrome Developer Tools extension, navigate to this website, log in as this particular user, and measure how slow the site becomes. So that's gonna happen. It might take a bit. It's gonna try to like navigate to the page URL, et cetera, et cetera. And we can let that happen in the background. As you see, this is really powerful that it could do all of this, but again, it's this plain black and white text that's not really interactive and engaging and all that. So while this happens behind the scenes, for time's sake, I'm gonna go into MCP UI itself. So let's add that, or let's talk about adding that interactive UI components for MCP. The folks who made MCP UI, one of them, he worked at Shopify. So a lot of, okay, it's going through the process right now. So a lot of the early examples of MCP UI have to do with like shopping and e-commerce. They're calling it like agentic commerce. So there's one example or one option of if you were gonna ask like, oh, I wanna buy this shirt, you'll get back a price, the description of the shirt and all that, but that's like boring. Who wants to shop and then not see what they're shopping for? I would never wanna do that. Like, I wanna see what the blue shirt looks like. Come on, right? So what they've implemented is basically this layer of interactive components that you could put in. So you could say, I wanna buy some shirts from Better Swag, and it'll show you the literal shirt. It'll also allow you to interact with it and press like add to cart and more. And just showing you a couple of code snippets just so you can understand like how it's working behind the scenes. Without MCP UI, you might just have this array and it will say like, oh, I'm gonna return some text that says like, if you said like, oh, what's the weather? It'll return some text that says, oh, in Boston it's 65 degrees and sunny. I really don't think it is. I think it's raining right now, but just as an example. And then for MCP UI, how it will work is you would import this library called create UI resource from MCP UI server, and you could still have the text as well, but what you would want is to maybe say type raw HTML and put in the HTML string. There's also other options where you can basically use an iframe to pull in like an external URL from a site that you already have, or use React on elements. I just use HTML because it will be more obvious. And then maybe you're looking at this example and you're like, well, it's all hard-coded. You would, of course, to make it dynamic, do an actual call saying like get weather from this particular city, and you can use templated strings. Same example here for using MCP UI. You do those templated strings within the HTML. Anyone lost? Okay, oh, go. I thought you were raising your hand like, yeah, I'm lost, so you did a thumbs up. All right, and the results would look like this. My teammate made like an MCP UI for open weather, and it basically like returns like this cute little thing within his MCP client. All right, let me give you guys an example that might resonate with you guys a little bit more than shopping or than looking at the weather, because for me, I'm like, I'll just go on weather.com. I'm not gonna ask like, Goose, what's the weather? For me, I am a new tech lead, right? So after I came off of maternity leave, now I'm a tech lead, and man, it's way more work than I expected it to be. I did not know I had to care about other people's work and feelings. I'm like, oh my goodness, there's a lot of feelings. With that, part of that is I have to like track like my team's goals and my work. So my manager's gonna be like, Rizal, we need to have like a bunch of meetups, so I can determine like how much meetups we have, etc. And what we used to use before to help track our work was Asana. I really liked it because it has all these colors, and it's really easy to be like, oh my gosh, Rizal's doing a panel, Ace is doing a blog, Tanya's getting Goose Swag for the team. Like, it was very easy for me to visualize. But then our company said, we're going to move to GitHub projects. And I like GitHub, but I'm not a big fan of GitHub projects. I cannot see anything, and it's gotten to the point where I think my team hates it too, because they're barely using it. They barely put in like what they're working on. I have no clue. My manager's like, where's everyone at? And I'm like messaging everybody. I'm like, did you finish that yet? I have no clue. So I was like, maybe I can make like an MCP server for this, where I can like just ask Goose like, hey, who has the lightest workload? What have people completed? And maybe I can make it a bit visual. So I'm gonna show you guys what I made. Oh, and behind the scenes, Goose was able to do the performance analysis. I just didn't wanna waste time with that as we have 10 minutes left. But it came back with saying like, oh, let's see, extremely slow login processing, delayed page transitions and stuff like that. So it's basically using Chrome developer tools under the hood to help me, and I can like follow up and say like, help me fix some of these bugs. But we're not doing that anymore. We're moving on to my GitHub calendar that I've created. So I'm going to ask it to, and you guys are going to see my, thought you guys would see my notes. I need my notes real quick, guys. Don't judge me. Yeah, this is the prompt I want to do. All right, so I'm gonna ask Goose to like show me my team's project calendar. And what should happen is it should literally render a calendar within like this iframe for me, and I've also made it a bit interactive. So let's just give it some time. It's working behind the scenes. It's talking with the LLM, like, what should I do? I don't know what to do, you know? Let's see. All right, here we go. Yeah, so, right? Way better than that GitHub projects board we were looking at. I'm not like roasting them or anything. I love GitHub. It's just not great, yeah. This is a little cut off, but like I could fix that in the future. But this allows me to be like, oh, cool. Like Ian is basically one of the only people putting his work in. But I don't know if I can zoom in more. I also have like these interactive buttons here where I can say like, let's like analyze the workload that the like team workload distribution, and it should come back to me with like, oh, here's who's doing like more work or less, and then I'll be able to be like, oh, this person, since they have a little bit less work, I can assign them more. So just waiting for that to come in. Yeah, so you can see here, like this is, it's kind of inaccurate since no one's putting their work in, but these are who are considered light, people with light workloads and then people with heavier workloads. And it comes back with like some key findings for me. So that to me was a more impactful use of MCP UI that I can use in my day-to-day rather than like shopping. All right, let me go back. Oh, I don't know. I think it was Command F1. Okay. We're almost done, and I'll open up for questions. Present review, and I'll drag this over here. All right, so I will just quickly end by saying like what I showed you today were really simple examples of being able to buy a shirt or tell me the weather, track my team's tasks, but with plain text, that intent that you have really stays flat, and with MCP UI it gives it a bit more dimension and transforms it into an interface of something that you can click and explore and act on. And the cool thing about MCP UI is it's really still evolving. It's in a really early stages, it's open source, so that gives us, if you guys are interested in it, the ability to really shape the direction of where it's going. That way, to me, like the way I'm thinking of it is like the future of user interfaces is you or us all together. And that's it. If people have questions, I have 6 minutes. Yes, I hope I can answer. Yeah, I should have had a little QR code. But this website's pretty easy. mcpui.dev has like all of their documentation around MCP UI. For MCP itself, I think it is, I don't remember. I'm gonna Google, sorry. Well, at least I'm still using it. I know, I should have asked Goose, right? I'm not in the future. The documentation for Model Context Protocol itself, if you want to know about that, is modelcontextprotocol.io. And of course, to plug my company's client, you know, you can go to block.github.io/goose. Oh, I thought you guys were seeing it this whole time. That's very awkward. Thank you. Okay, sorry, let's go this over. mcpui.dev. Cool. Modelcontextprotocol.io. And then the other one, I'll tweet it out or something like that so you guys can access it very quickly. And then the other one is block.github.io/goose. You could download the MCP client, and we also just have like a really good blog on like different like things about MCP UI and just other things about like agents in general, like sub-agents and all that gets really technical. Anybody else? Yes. Yeah, that's a really good point. I actually didn't even think of it from that perspective, but it does add a really good storytelling aspect and dimension beyond just like getting that text back and like, oh, your AI agent can do things for you. It's like you can also like interact that way and I don't know, give more flavor. Yeah, I like that. Yes. Ooh. I have not played with AGUI before, but I'll put that on my list. You played with it? You like it? Okay. Yeah, I don't know. Leon. So far I've had it just be generated on the fly each time, but I'm hoping they continue to improve on that. Good question. I don't know. I don't think it supports. Wait, how does GSAP work? I've never used it. Is it like a framework? Oh. Use that? Yeah. Oh, yes. Yeah. I don't know if they have that yet. I know they have support for like HTML, React, and web components, but I don't know like how deep the support for GSAP is. But like since it's open source, you can like open an issue. Maybe I'll just open an issue now. I don't know. Let's say I can make it better, but I'll say let's create support for GSAP. All right, I think I'm nearing like the end. And that's it for me. If you guys have more questions, we can chat outside, I guess. Thank you.
learning architect at Netflix, where I work on Gen AI for Hollywood. And today we're going to be talking about AI in your browser with WebGPU. So before I get going here, a quick just survey. How many people have heard of WebGPU before? Okay, just a few. Great. Well, I hope you kind of walk away from this talk today really excited and inspired about what can happen here and what's possible to do with just web tech. We're going to be moving pretty fast for 25 minutes, so I highly recommend hitting up that QR code to follow along with all of the slides and code that we'll be walking through, just stashed away for later as well. But a little bit first about sort of my inspiration for where this talk is coming from. So while I'm churning out AI models today, my past life was all about open source web tech. I worked on Chrome itself. I built tools like Lighthouse, which help you analyze your page for web performance issues. And I did a bunch of open source JavaScript, NPM packages, millions of downloads. So to say that I'm a little homesick living in Python land is definitely a little bit of an understatement. And thankfully, these two worlds are merging, and that's what we're going to be talking about today. So they're colliding in some really exciting ways, getting to have AI and machine learning happen actually on the web with JavaScript APIs. So my goal today is to get you so giddy excited as I am about everything that's happening with WebGPU. And this is how we're going to do it. We're going to walk through evolution of the web, talk about just some technologies that brought us along the way with a focus on one in particular called WebAssembly, or WASM. We'll see what that did and how that kind of paved the way a little bit for what's happening on WebGPU now. And then we'll actually talk about WebGPU itself. What is it? How do you use it? What can you do with it? And we'll make that a little concrete with a real example walking through different pieces to assemble a video captioning app. And we'll do a live demo. Fingers crossed that that goes well. Nothing ever goes wrong with demos. And then we'll talk a little bit about the future and what we kind of expect to see from all of this, get a little introspective. Quick note though first, before we do all of this stuff, I know Commit Your Code is a very beautifully diverse group of people with different experiences, so it is inevitable for some people I'm going to be telling you things you already know, and for some people I'm going to be using words and assuming knowledge that you have no idea what that is. So if that second group is you, don't be disappointed, be super excited. I'm thrilled when I come across words that I have no idea what they are in a talk. Opportunity to learn. This QR code's for you. There's like a jargon buster list at the end of this link, so if anything is confusing or you don't know what any of these terms are and I'm using them, feel free to hit up that long list of links that kind of explain what all this stuff is. So with that out of the way, I hope you get to impress someone with your knowledge later that you pick up. Let's get into how we got here. So it's going to take us a while because we're starting all the way back in 1989 with HTML. We didn't even have JavaScript or interactivity or styles yet. A few years go by, the web's getting a little more capable. We can actually click buttons and do things a little more interesting. It's not just documents. And then we enter what I call the dark ages. I'm not naming any names or pointing any fingers, but not a lot of APIs that were written during this time period you might be remembering or using today. And then we hit the golden era, right, where we had pretty much everything you're probably still using with Node.js and React and web fonts and Angular. We're going to talk about one kind of at the tail end of the golden era in particular called WebAssembly. And this really kind of paved the way for what we're going to be talking about with WebGPU. So what is WebAssembly? WebAssembly was a new technology on the web that let you compile traditionally compiled languages for desktop into a target to actually run in the browser. So apps that are written in C, C++, Rust, Go, instead of compiling them for a local desktop, you would compile them for the web. And this is what it kind of looks like. You would have your regular statically compiled code, and instead of using Clang or GCC, you would use mscripten, which basically takes your input language and converts it to a WASM file and some helper HTML and JavaScript. And it looked something like this. Kind of horrifying 2,000 lines of 114 kilobytes of code to print hello web to the console. So it's very powerful, but it's also a lot. So you got to have some really good reasons for using it. And thankfully, there were some really awesome reasons. Adobe was able to port Photoshop to the web. Millions of lines of C, C++ to run in the browser and became kind of a cornerstone of their cloud effort. Because of WebAssembly, you can ask Claude Code today to get a fully featured video editor in about an hour using FFmpeg. So plenty of amazing things that you can do, because anything that was targeting the desktop could now actually run entirely in the browser. But there was a big problem with this. WebAssembly was basically allowing you to target CPU instructions, and CPUs have like, I don't know, maybe 100 cores if you have like a server rack and something really nice. What if we want like more than 9,000 cores? Like what are we gonna do then? And that's what WebGPU is gonna let us do. So WebGPU is giving us direct access to the GPU's parallel compute in the same way that WebAssembly gave us a web target for CPU instructions. WebGPU is giving us a target for GPU instructions. And this is why I'm sort of comparing this. If you're familiar with kind of graphics on the web, you might be saying, why are you not comparing this to WebGL or something that is much more graphics intensive and using the GPU already? Well, that's because it's not just for graphics. So you can do all the regular graphics things that you would do with WebGL, also with WebGPU. But it opens up the door for lots of other cool things that you can do with GPUs. I think everyone knows what that is, but we'll talk about it in a second. This is great timing to have this talk too, because it is finally cross-browser. So WebGPU is not just like some Chrome-only experiment. It shipped in Firefox in July and is available in Safari and macOS Tahoe. So all the major browsers support WebGPU, and it's a bright future going into it. And this is what it looks like if you tried to use it for a graphics purpose. So I don't really care if you understand anything that's happening on the left part of this slide. I really want you to have two takeaways. One is that we've come a long way from WebAssembly. There's no like CLI you have to do. It doesn't generate 2,000 lines and 100 kilobytes of code. We basically have one string being passed into a JavaScript function, so the ergonomics are much, much improved. I'm still cheating a little bit because there's like 100 more lines of boilerplate that didn't fit on a slide, but hey, it's not 2,000, and you get the gist. The other piece is that it's not just graphics. So this is drawing a triangle. Big whoop. Triangles aren't that awesome. But you can do some really cool other stuff. These are some WebGPU examples that you might have done previously with WebGL of lava metaballs and games and physics simulations and all of that. But that's not the only thing that we can do with WebGPU. Who else thinks we can do something really cool with WebGPU? Anyone? Timid. Oh, okay, get into it. Raise those hands high. AI, right? That's why you came. It's the title of the talk, right? AI runs on GPUs. So neural networks are basically massively parallelized matrix operations, and that's exactly what GPUs are going to be great for. So WebGPU, unlike WebGL, lets you run these same type of operations in a much more efficient way. So we can actually run AI directly in our browser, meaning no server inference costs, no expensive API bills, and everything can stay locally on the client. You never even have to leak it. So to take a look at what that looks like, we're going to be leaning on this concrete example of media search, which is actually a problem that my team is dealing with and hiring for, FYI, if anyone's background and interested. Consider this your interview cheat code. And Netflix obviously has a ton of video. And so when people are trying to find that exact perfect clip of the Thunderstruck opening, if you know what I'm talking about, you'll know more in a second. And video captioning is key to that. So basically take a video, generate some text that describes what's happening so that we can help people searching and find those videos a little faster. So we're going to help them out here, and we're going to use a couple different web APIs put together to make this happen. So first we need to access a video. We'll use the file API for that. Then we need to pull out some images or frames from that video. We're going to use Canvas for that. And then we'll get to the interesting part with WebGPU and actually run those images through a large language model and figure out our captioning. Another quick gauge of experience here. How many people have heard of all three of these before? How many people have used all three of them? Okay. How many people are like, I could do this, talk or no talk? Who needs Patrick? Okay. Whew. All right, still have a job for now. Okay. Well, let's start with the simple stuff, file API. If you've been a web developer for a little bit, you've probably done something like this. There's an input element type file. It lets you get some HTML. And it's going to trigger the OS UI to pick a file from your file system. In JavaScript, you can listen for that change event happening, grab that file, and actually do something with it. So we're going to create a video element out of it. And if this JavaScript looks a little funky to you because you joined Team Web in sort of the post-framework era, definitely recommend, side note, brushing up on some vanilla JavaScript. It's worth your time. You'll love it. Your LLM devs will love it. It's great stuff. But it's straightforward to do using on-change and React or Angular or any other framework too. Once we have a video element, we can then try to extract some frames from it. So we're going to do that using the Canvas API. So we can create a Canvas element, do some context, set some height. But the part I want you to focus on is right here, where we're taking the video, we're setting the time to a particular point in that video, we're drawing that video to the canvas, and then we're pulling out an image from it. So we're going to grab 3, the beginning, the middle, and the end, as like a good starting point to figure out what's going on in our video. And then we're going to have a little Pythonic diversion here. So how many people have done like back-end development in this Gen AI era for running LLMs and models? Okay, good, like half. How many of those people have used transformers? Okay, like another half. Okay. Well, we're going to stand on the shoulders of giants here because Hugging Face is a sort of open source AI native company that's been pushing a lot of the model hubs and a great place to go for learning resources and all kinds of machine learning topics. And they have built a library called Transformers, which reduces a lot of the complexity of working with any of these AI models down to like 12 lines. So this entire thing is basically gives you a little mini chatbot, right? Where we're going to reference a model that exists on Hugging Face. So we're just going to say model equals from pre-trained and give our label. We're going to get some message of text that we want to tokenize. We're going to convert those to tokens and hand those to the model and ask for the next response. And that's it. And if you have ever tried to do this from scratch, it is an amazing amount of complexity that is hiding and giving you a lot of power to do. Lucky for us, there's a JavaScript version called Transformers.js that looks shockingly similar. So we're going to import the Hugging Face Transformers library. We're going to have a pipeline that references a model that exists on Hugging Face. Important, we're going to say the device is going to be WebGPU, and then we're going to give it some text. We even get to skip the tokenizing step. So we got lucky again. It's even easier than the Python version, simplifying it further. But we still have a problem here. This is just text, and we wanted to deal with some images. So we're going to need something a little better than a large language model. We need a vision language model. So a vision language model is a large language model that's been trained with both images and text, so you can work with both at the same time. Not all open weight models that are available on Hugging Face are as powerful as the frontier models that you experience in ChatGPT and Claude and things like that. So it's an important distinction that we need to be sure whatever we're grabbing actually gives us this capability. And lucky again, guys, we're getting so lucky. It's almost like I planned to have this talk at this time. Over the summer, Apple released a new paper called FastVLM, which was a new vision language model that's 10 times faster than the previous state of the art. And so fast it can run on an iPhone in a fairly reasonable amount of time. So this is going to be perfect for our web use case where we want small, fast models that can give us a response in a reasonable amount of time. To give you an idea of how important this is, if you've ever, how many people have tried to run like Ollama locally or run an LLM on their own device? All right. Did it kind of generate tokens like this? Yeah, pretty painful, pretty slow. So we're not going to have that problem here. And thankfully, it's pretty easy to swap in and out. We're like, I don't know, quintuple lucky, septuple lucky. I don't know how many times it's going great for us. Instead of generating text, we're going to go image to text, and we're going to change our reference to reference Apple's FastVLM, and then we're going to pass in our image element and a prompt for what's going on. And that's going to be it. Or is it? One more wrinkle. That's just an image. I thought we had a video. How are we going to get the video? I dropped a hint earlier in the slides for how we're going to do this. I'm sorry? Yeah, and what are we going to do with them? Process them one by one. We could, and then maybe like combine the caption later. That's definitely one approach. We're going to do something different. We're going to do a film strip. We're going to combine all 3 images in a row and pass that to the VLM all at once and say what's going on in this video. There's actually plenty of discussion about which approach is better. So it's completely valid to say I'm going to send all of them individually and then try and synthesize a caption from what's going on in each individual frames. We don't have time to dive into the deep details of the absolute best video captioner, but we're going to give this a shot with our beloved Dallas Cowboys cheerleaders from America's Sweethearts on Netflix. If you haven't seen it, it's amazing. If you love football, I swear it's the new Hard Knocks. If you hate football, they're still amazing athletes and people, so check it out. And we're going to try a live demo. So let's cross our fingers and hope it works. I sacrificed 2 rubber ducks to the demo gods this morning, so we're... All right. Okay, so we're going to drag in our video, extract our frames, processing. Hey, okay. Slightly slower than I wanted, but cheerleaders perform an energetic routine with their arms raised high as they jump off the ground. So we got some motion showcasing their agility and teamwork. Audience watches intently from the stands. We got a caption, everyone. All right. Amazing. Woo! Thank you. Yeah, let's get some energy. Magic indeed. All right, so future is even brighter. You might be thinking, well, Patrick, that's great, but like my customers don't have GPUs. What are you talking about? This is useless for me. Well, I have good news for you because WebNN is on the horizon. Yet another API for you to learn and another talk in 2 years when it becomes cross-browser. So WebNN stands for the Web Neural Network API. It's already available in Chrome and Edge, and this is going to let you leverage any hardware acceleration to run these models. Not just GPUs, but NPUs, neural processing units, and falling back to CPU where necessary. What this concretely means for you is all the marketing fluff AI PC is actually going to become really useful for making web apps because you'll actually get to tap into the NPU and run models on some specific hardware designed to run those models. It is experimental, so you got to do a little tinkering to get it to work. You got to go to Chrome flags and search for WebNN and just enable everything you see. But it's been working pretty great for me, pretty stable. And to give you a sense of how much power you actually get out of this, this is sort of an evolution of the web starting back from just pure JavaScript. So this is the performance on an image classification task in frames per second or images per second. And web classification is the very simple case of here is a picture. Is it a hot dog or is it not a hot dog for my Silicon Valley friends? And a lot simpler than our LLM and our video captioning, but still representative of a lot of computer vision and similar tasks you need to do. In pure JavaScript, I had to do this. I hope you never have to do this. It's pretty slow. You can go about a third of a frame per second running a neural network called MobileNet in pure JavaScript. That's 3 seconds to process a single image. Once WASM came around, WebAssembly, we were flying. We could do 20 frames per second. It was amazing. It was almost real-time video. And that's 100x improvement. That's 2 orders of magnitude from WebAssembly. And then WebGPU came along, and we got another order of magnitude faster, 200 frames per second we're going. With WebNN and an NPU on this MacBook from 2 years ago, more than 1,000 frames per second we can do in image classification. So exciting times ahead for real-time possibilities on AI and all local and private to the browser. Now, I don't want to sugarcoat everything. There are some realistic limitations with what you can do here. The number one being models are big. So the small model that I talked about with FastVLM is still 300 megabytes. So not exactly something you want to be triggering on a mobile phone and downloading over 4G. The second big one is that accuracy still leaves a lot to be desired. The smaller they are, the less accurate they are, right? The one we were using in our demo was about 1 billion parameters, and Claude and GPT-5 are rumored to be in trillions of parameters, so obviously they're a lot more capable than what you can do on the smaller ones. But that's kind of the trade-off we're facing here, right? If you have some use cases that are, which the vast majority of them are, if you use Claude Code, 90% of the queries answered by Claude Code are actually delegated to their smallest model. So there are plenty of tasks that you use in this context that can still be successfully answered by smaller models. And if you choose that path, you get all web, no API bill, privacy preserving, all staying local on the browser, which is a pretty great win. So my takeaways and predictions for you are, number 1, AI is coming to every web application, not as some expensive add-on, but as some core capability. One of the most exciting things I think that's happened with LLMs is that we get this sort of common sense primitive for programming that we've really lacked to do all kinds of fuzzy UI improvements. The next prediction I have for you, privacy preserving AI. So when it's actually feasible to write apps that run AI client side, I think we're going to see a more proliferation and actual emphasis on some of these use cases that it's really important to preserve the user's privacy and not keep a giant log of all of their chats. And my third prediction is that we might see actual democratization of some of these AI capabilities, not just well-funded VC companies who are throwing away lots of money on GPUs for bad unit economics, but any hobby app can take advantage of some of these things for free and on the web. And my fourth and final prediction is that you guys go build something awesome. So there is, I was told to plug this, there is on the section of the Commit Your Code website, there is a spot for feedback and getting the slides and viewing the recording after. If everyone could take out their phones and give me their honest rating of whatever that is, I would greatly appreciate it. I'm sure Commit Your Code organizers would too. And then we do have 3.5 minutes for questions, if anyone has questions. Yeah.
I made a comment to someone else in another talk that I felt like the way AI is going reminds me of around 2018 to 2019 in front end, where you had a vanilla framework with the weeds sweeping in and there were massive changes in the ecosystem. AI kind of reminds me of that era of the web. How are you keeping up with the trends? Like, obviously, that's your full-time job, but even then it's really hard. Like, what are your recommendations to try to keep apprised as to what's going on right now?
Yeah. That's a great question, and the short answer is I don't even feel like I'm keeping up, and I'm, you know, it's my full-time job. I think part of it too is at some point you do kind of need to pick an area of focus. Like, obviously at Netflix we're very focused on media and video and image, and that's progressing very differently than say all of the LLM advancements, and we're very focused on media generation and media understanding as opposed to kind of everything that's happening, for example, in the development space with LLMs. So I think if you want to actually keep up with the state of the art, you do need to at least pick some subset of it and say, this is what I'm going to focus on, kind of actually following new developments, figuring out what's going on, and keep tabs on everything else. Like, I'm not, you know, blind to what's happening with, you know, LLMs elsewhere, but it's impossible to, like, you know, read every paper about everything and understand exactly what's happening and also get real work done. So I think part of it, you do have to kind of pick a focus area and figure out what's exciting to you and what keeps you motivated, and say, okay, I'm going to really focus on trying really hard to read these types of papers and follow these GitHub repos that are touching this topic, and the other stuff, maybe catch the summary, you know, listen to like the highlights, and, you know, get your download from friends who have chosen to focus on other areas. So that's what I do. Good question. Yeah.
200 MB feels too large to download a model in a browser. How can it be optimized for, like, maybe it's going to take, first time it's going to take 2 hours time to download, but how are you going to make it faster the second or third time?
Oh, well, so it's stored in the browser cache, so it's only downloaded the first time. Like, I actually did this, I could have done this demo with Wi-Fi off. I don't remember if I turned my Wi-Fi off or not, but once it's downloaded, it's stored in the browser cache, and you don't actually need to download it again. And the browser cache is fairly durable until the user, like, explicitly clears it, and so then they're going to have to go download it again. I'll also say, like, large language models are pretty much like the worst offender here. There are plenty of other kind of computer vision smaller models that are a little more reasonable in terms of size, that aren't so painful to incur that cost. But my kind of long-term prediction is this is more used for, like, intranet apps first, right? Like internal, where you're expected to sort of have a fast connection to whoever's hosting this. Maybe it's even local host, but it's just like a local app kind of running on each business machine, and then eventually make its way to more kind of consumer-friendly applications, and like a warning like, hey, you're about to download, you know, use 1 gigabyte of your data plan for the month. Like, are you sure you want to do this? That sort of thing. Yeah.
So when you mentioned that you're working on like captioning, is it for live video or is it for video that's already like released?
Well, this example is just for, like, for example, searching like the Netflix catalog. Imagine you wanted to find like all clips of you know, cheerleader jumping, right, in all videos, that sort of thing. Yeah. 15 seconds. One last question.
Do you like working at Netflix?
I do. It's great. It's fun. The best part is like the secret stats on everything. So like, we have like a family movie night, and every time we watch a Netflix, like, we're going and seeing, okay, all right, how popular is it? Did it beat this other one? You know, it's fun. Yeah. All right. Well, thank you all. Appreciate it.
My goal today is to convince you guys that in your code today you can communicate pretty reliably with large language models and even pre-trained AI models of any type. and use them in actual applications you're building for businesses today, or if you want to build them on your own, right, and just play around with these things, see ways that you can more reliably make your code communicate with these models and do something, pretty significant. So just a quick introduction. My name is Jacob Warshalik, and I am a bike-crashing, coffee-fueled software consultant. And I ride mountain bikes, and I do stupid things on mountain bikes, so I tend to go over the handlebars from time to time and hurt myself. My friends joke with me all the time because I show up with a brace or a sling or something like that, and so that's where the bike crashing comes from. I'm also coffee-fueled on a regular basis. I work at coffee shops on a day-to-day basis, and I drink probably entirely too much coffee. And I actually just had a very large iced coffee before this, so I apologize in advance. I'm probably going to be talking fast. But I got a lot of content to go through, and I only have 25 minutes. And as far as what you guys care about, I am a software consultant. My company is Focus Dev. And I've been doing this for about 17 years as an independent, and the last 2.5 years I've spent building solutions for real-world clients with pre-trained AI models. And so a lot of the stuff we're going to be talking about today, this is stuff that has really happened, right? I've done this for businesses, and it works. So hopefully it convinces you that you can do it too. And there is a book that's floating around here that I wrote with a couple of other really talented authors. They did sell out yesterday, but if you're still interested in getting a pre-release copy and also a pre-order one, you can get the digital access immediately, and then you'll get your actual final copy in March. Actual footage. All right, so I'm not here to hype up AI in any way, shape, or form. The truth is, the AI companies, they're already doing that, right? I mean, if you listen to guys like Sam Altman, they'll tell you that, AGI is the next release away. It's coming in a couple months, a few days. And then the next release comes out and we're all underwhelmed. Yeah, it's better, it's faster. It maybe does a few things better that we've tested before, but it still makes mistakes, right? There's still hallucinations. We still see problems with it, right? Using something like Claude Code, you get deprecated usage of APIs coming back. And you're like, why is this happening? Well, there's good reason for that, because these models have limitations. And we have to understand those limitations. And we've all seen behind the curtain to some extent, right? When we've had these issues. So, I'm not going to be a snake oil salesman here, right? I'm somewhere in the middle. You've got your cheerleaders in the AI world and you've got your naysayers, right? This is what gets clicks in social media, right? Everybody loves to be on one end or the other. I consider myself a practical AI advocate, right? I'm all about what works in the real world today and where does this thing fit. And the goal is, as a software developer, is I have to understand the tools that are available to me and know where they fit, right? And that's what all of our jobs are. As software engineers, we just have to understand what tools we have available to us. And I've been doing this a long time, right? I've been developing software for over 20 years, and there's a lot of hyped up tools that have come out over that time, I can assure you. And every time one of these comes out, businesses will come to me as a software consultant and say, hey, we want to use this thing. They might even be telling you this as an employee, right? We need to be using AI. You ask them, well, how do you want to use AI? I don't know, but everybody's doing it, so we want to use it, right? Microservices was a thing, right? I mean, name your flavor of the week. But we just have to understand as developers where it really makes sense, right? Because our goal is to solve real business problems, right? We have to understand their problem and find the right tools that fit. So I consider myself what I would call an AI chef. I am not an AI architect. These are the guys that are getting paid hundreds of millions of dollars that you see in the headlines that are getting stolen from OpenAI over to Meta, over to Anthropic, wherever, right? And if they want to pay me hundreds of millions of dollars to come work for them as an AI chef, I'm happy to do that. Please call me, right? I'll take the money. But that's not me. What I do is I integrate these models, the pre-trained AI models. I don't train them myself. I manipulate them in ways that work in order to build solutions with models that already exist, that somebody already built. And I might fine-tune them in some way, but really, I'm just using pre-existing AI models. And you can too as a developer, through SDKs and APIs. That's what we understand, right? As developers, we understand SDKs and APIs, and they're all made available to us that way. So let's talk about a real story, right? I have a client that builds commercial real estate software. And if anybody in here, any commercial people that work in commercial real estate or know the industry at all, okay. They get all these documents in on all these properties, on the rents that are coming in and all this information, and it comes in Excel, Word doc, and PDF format. And none of these formats are standard, right? So you're getting all this data in all these wacky formats, and then the goal of this company was to build a software system that centralizes all this information, puts it in a standardized format so that they can start comparing properties and how they're performing and, you know, all the stuff that business people want to do to see how their profits are doing, right? And if they need to sell a property or what needs to happen. And so one of these documents that they needed to worry about was commercial leases. And commercial leases, if you've ever signed a lease, like for an apartment or anything like that, you know it's your agreement with the landlord on, hey, I'm going to live here for a period of time, I'm going to pay this rent, what are your obligations, what are my obligations, right? All that information is embedded into the lease document. And so what was happening is they had people coming in that, you know, were having to input this data. And if you're familiar, you know, as software developers, a lot of time we're automating data entry tasks, right? That's what we do. But these lease agreements, they have similar information, but completely different formats. And they can be 50 to 80 pages of information in legal speak, right? And if any of you have read legal speak, right, it's like Shakespearean. It's not like any of us talk, right? The words are in backwards order in sentences. It's just very bizarre. They spell out numbers instead of writing them as numbers. So people were messing these things up, right? They were going through and trying to find all this data and input it into the system, into the standard, you know, data sets that they needed. And they were taking hours to do this and just, you know, not making mistakes, right? That's part of the nature of manual data entry, is just making mistakes. So they really wanted to automate this. And this is a very, very pared down version of a commercial lease, right, for Troy Aikman, who we all know and love here in Dallas. But it's the idea of the information that's in a commercial lease. And this is what's called unstructured data, right? It's not in any kind of structure that we would like as developers and that we would generally use. It's just text, right? Free-form text, and none of the formats are the same. So no matter what lease you look at, it may be close, right? If you happen to be dealing with the same landlord and they have the same agreements, but it's going to be different, right, across the board. So you can't rely on code to be able to parse this efficiently. You know, you may try to write a bunch of regexes or something to pull the data out of here, but it's not going to work for all the leases. It's just not. So what we really want is something that looks like this on the right, right? We want to take this unstructured data and be able to extract this information. That's really the problem they're trying to solve. Because, you know, in the world of code, we need something that looks like this. If we're going to put it into a database or operate it on it, right? If I want to get the rent schedule, I need to know where it's at in a data structure to be able to pull the data out. So before we understand how you could do that with a large language model, let's talk about some background on these models first, that we understand why this would work and why we were able to solve that problem with a large language model, to take those leases and turn them into that structured data format. So all of us likely had our first LLM experience in 2022 when ChatGPT was released, right? It probably looks something like this, right? This is now kind of a, you know, known interface. Everybody's messed with this thing, but you know, whether you believe in the power of large language models or not now, but everybody, I guarantee you, signed on this, asked a question, you were amazed, right? I certainly was, and I'm in software. I asked it a lot of questions, and I was going, God dang, man. I don't know if my job's at risk or not, right? What's going to happen to me now? They've figured this out, right? Suddenly, AI models are a lot smarter than I am. But the truth is that, you know, there were quirks, right? And we didn't realize it till later on. But what happened is that OpenAI had figured out how to give us an interface into this amazing thing under the covers, which is a large language model. And the large language model, the idea behind the large language model started much earlier, back in 2018 when BERT was released. And this was really an amazing discovery, because the creation of BERT solved a problem that AI researchers thought maybe could never be solved. In fact, many, many people left the industry because they thought the understanding of language was just impossible, right? It was not going to be something that can truly be solved by AI models. And if you really want to know about, you know, the history of all this and how transformer models work, feel free to check out this paper and, you know, go through these models and understand how it's happened over time. But as time has gone on, just know that, you know, they've kept adding additional training data and scraping additional training data to make these models better and better at understanding language, and that's been the goal. But why was this problem so hard? The reason is if I say something like, I'm walking to the bank to deposit some money, to a machine that thinks in ones and zeros, it says, okay, great. So a bank is associated to money. context matters, right? So it's saying, okay, bank and money, they're somehow associated, right? And we would agree with that as humans. It's a financial institution. It deals with money. But then if you say, you'll catch more fish if you walk down to the bank. For a machine that thinks in ones and zeros, suddenly a bank, the word bank, is associated with money and fish. We know that immediately. We're going, wait a minute, no, we're talking about a river bank, right? This is not a financial institution. The English language is full of these kinds of things, different usages of words depending on context, okay? Context is really important. You have to look at the sentence, you have to look at the paragraph around it, maybe even the entire document to understand what a word means in a particular situation and what a sentence means. You know, there's colloquial things that we say that, you know, might be a saying that would make no sense outside of the context of where we live or, you know, how we talk to each other, right? It's all built into our culture. So context, which is a word you'll hear a lot in the world of language models, is all about understanding meaning. And when they solved this problem with large language models, it was an incredible advancement because all of a sudden these models were able to understand words within sentences, sentences within paragraphs, and understand like we do just how these things are fitting together. And they did it based on all this knowledge and stuff that we've put out on the internet, right? There's tons of articles and books and all that they could scrape off of the internet that provide examples of this, right? How do words fit together into sentences? How do sentences fit together in paragraphs? That's perfect training data, right? That's why they used all this information in order to train these AI models. So when you hear all of this, all of these words and phrases about context, it's really about creating understanding and the understanding that the model has about what you are saying, right? And how you're prompting it and how it, you know, makes sense of all that. And the big word of today, or the big buzzword of today is context engineering, which is how you provide information to these large language models to make them do what you want them to do. Okay, so ChatGPT, and you may all be familiar with this, but really it's a really fancy interface that does a lot of things to kind of hide the limitations of LLMs behind the scenes, but it's really just an interface that talks back to a large language model through an API, okay? And we can use SDKs, or we can talk directly to that API if we want to, but we can send it a prompt through the API, or we can call an API just like this and send it a prompt, who are the Beatles? And it, you know, the LLM has enough training information from the internet to know who the Beatles are, right? They've been a big band since the 1960s. There's Rolling Stone articles, Wikipedia articles, there's lots of information out there. So it can give us a pretty good, you know, detailed explanation of who the Beatles are and a lot about them just based on what it's been trained on. And we could do the same, right? We could build our own REST API service or an interface on top of it if we wanted to build a chat interface to do exactly the same thing through a local model like Llama 3.2, or we could even talk to OpenAI APIs if we wanted to, just like they do, right? There's a lot of examples of this. You can build your own chatbot anytime you want. In fact, if you want to look in the book, we help you build a chatbot and kind of show you how to go through that process. But this situation is just natural language input and output. And these models, that's what they're good at, right? They've been trained on all this language on the internet, and they understand language like we do. And so for situations like question and answer, summarization, rewording, even code generation, they can do all of this, right? We know we can send in a prompt and instruct it on the response we want, and we get it back in kind of, you know, just it talking to us, right? In our language, in natural language. But what happens when we want this, right? We need something that looks like this in order for our code to continue to do stuff with the response that comes back from the model. So we can call into that API, but we want it to give us back this. So there's a lot of unstructured data out there that could be useful to us, right? Like those lease agreements. But it's all contained in emails, documents, text files, social media posts. 80 to 90% is the estimation of all data that's out there is unstructured, right? And we need a way to make it work with our code, because our code can't naturally parse all that unstructured data and do something with it. It's very difficult to do that. So the goal is that we need a way to prompt an LLM, to send a prompt over that gets that. And we have to do this knowing, number one, that the large language model has limited training data, right? So all these models are trained on scraped internet data, and it costs a whole lot of money to train them. So they're trained once, and then they're kind of stuck in time. Like if it was trained on data up until 2023, that model only knows the data up until 2023. And in addition to that, it doesn't know anything about your proprietary information, right? So like if you're sending it a lease agreement and you say, hey, operate on this lease agreement, it won't know about that lease agreement the next time you call it, right? It's stateless, it's stuck in time. So keep that in mind, right? It doesn't know from request to request what you've said before. So you have to structure your prompts knowing that every time you have to tell it what to do over and over again. And in addition to that, we have a limited context window. So you can't send the entire world of information to a large language model in your prompt. You have to limit it to just the information you need in the prompt in order to accomplish what you're trying to do. So we can use structured output support to do this and to help us get through this problem. And the SDKs to most large language models do support this. And you can do it with the Llama SDK, the OpenAI SDKs. They all support it, and Instructor is actually a library that I recommend. Instructor.js is a really good library that you can try out, but it's built around this idea of generating structured output. So it kind of takes care of some of the things for you and makes it a little bit easier to do. And then also high-level libraries like LangChain support this. But whenever we want this JSON output on the other side, the key is structured output gives us that support. So let's take a little bit of a simpler example than the lease agreements, right? Because I said those were 50 to 80-page documents. Let's talk about emails. Let's say that we want to parse through some emails and go and extract out the name, title, company, location, phone number, and email out of every email that's coming in. And maybe we want to do this because our team that deals with sales, they want to communicate with clients, right? They want to know up-to-date and accurate client contact information. So when an email comes in, we want to be able to pull out that data and load it into some data store, maybe a CRM or something like that, right? And if we have humans do that, most of the time they're probably just going to ignore you and say, I don't have time for that crap, right? I'm not going through that email and just trying to take all that information and input it into some system. And if you try to have software do this, it's really difficult without a large language model. And the reason is, if you look at this email, you say, oh, well, some of the information I want, it's down at the bottom, right? Maybe I can just extract it from there, but then you've got a location kind of embedded up into the body of the email up top. And the other thing we have to think about is again, emails aren't required to be this format, right? They're not required to have a signature. They're not required to have anything in the email other than just whatever text the person decides to write, whether that's good or not, right? I mean, I've seen some really bad emails that have no information, no useful information in them. But what we want to do in this case is be able to take that email and pull out something that looks like this over on the other side so that we can put it off into a database or operate it on it, maybe send a follow-up email, respond in some way. So you see we have sender name, job title, company, email, phone number, and location. A large language model can do this for us, and it's because of that understanding of language, because it looks at the context like we do, and it says, hey, I know that Sarah Whitfield, that's a name. And I know that Director of Customer Experience, that's a title. Same thing for Acme Software Solutions, that's a company, right? It looks at this in the same way we do and understands the language that it's looking at so that it can pull out this information that you're asking for. But we just have to know how we can instruct it to always give us a response that looks like this and to look for those specific elements that we want out of this unstructured data. So again, those are the pieces that we want out of this email. And it can even operate on something that looks a little bit like this. So in this email, it's even more difficult, right? Because like I said, they can format that email however they want. But down here, we've got the person's name and email. And then up in the embedded in the text, we've got I'm the Director of Customer Experience at Acme Software Solutions. Immediately as humans, right, we look at this and we say, oh, well, obviously, that's the title and that's the company, right? But to our code, can anybody in here write a regex that's going to pull that information out? Raise your hand. I want to know. No, right? It's virtually impossible to do that reliably. So the great thing about a large language model is it can do that kind of thing for us because of its understanding of language. It thinks about language in the same way we do. So now let's actually talk about the code, right, and how this happens. Really, what you have to do to make this happen is send in a JSON schema. So like I talked about, these large language models are trained on a lot of information from the internet. right? And a lot of that information out on the internet is code, right? Because we've all contributed to open source software and put a lot of code out into GitHub repositories. And so these large language models have also been trained on all of that. And it's just really a form of language, right? It's a very structured form of language, but it is a form of language. And so they understand JSON, and they kind of know how it works. So what we can do is they fine-tune these models on back end to make them work with JSON schemas so that if you send in a schema as the output format, it says, oh, okay, that's how you want the response? Great. I will structure it exactly how you're telling me to do it. And so it will follow the schema that you're giving it. So what does this look like? It looks like this. This is what a JSON schema looks like. Now, this is a very simple one, right? And you can only imagine for that lease agreement that we were looking at before how complex that JSON schema would be. But I don't really want to write this thing, right? I mean, I don't know about y'all, but I've written schemas before. Like, I'm old, right? I'm dating myself. I wrote XML schemas a long time ago, and that's ugly stuff, right? Schemas are a pain in the butt to write. We really want something to create this for us. And so we can. In the world of JavaScript, you have a library called Zod. And Zod allows you to define schemas and describe what your objects look like. So here we've got a contact information schema that basically says exactly what we want, right? We've got a sender name, location, job title, company, email, and phone number. And look over on the right. We've also got a description of each one of these. And you can put as much information in that description as you want, and it will be sent along with your prompt. And it actually helps the large language model to understand how to get that data. So if you had like a hard data element that was, or let's say phone number, right? Let's say phone number you wanted formatted in a certain way, regardless of how they send it. Because you can see phone numbers with dots, with dashes, with parentheses, all that. You could actually put a description in here that tells it, hey, when you give me back the phone number, provide it in this way. And you could give examples. When you see a phone number like this, make it look like this, and do that over and over again. That way it knows, number one, that when I get a phone number, this is how I get it, and then also, here's how you want it formatted on the way back. And it will do that. It will give you the phone number in the format that you want. And then also look that we've specified optional on all of these. So, these things may or may not be found in the body. So by telling it it's optional, it understands that it may or may not be there. And this last line, the toConsole.logs, that's how I output this JSON schema that you saw on this previous slide. So I didn't have to create this thing, right? All I had to do was create this Zod object, and then I could directly output the JSON schema. And I can even use this whenever I create my object, right? So you can create objects from these schemas automatically, and then you have a JSON object to work with. And this, let's see how much time I got left. Okay. This is actually how you would send it into OpenAI. So here you say you basically calling into the OpenAI API to do a completion creation. And in this case, I'm sending in, number one, a basic message that say, hey, given an email message, you will extract the sender's contact info, and then I give the email in the body, and then I also give it the JSON schema down here in the response format. And this instructs OpenAI that, hey, this is how I want it to look on the way back. Here's the schema, give it to me just like that. Okay? And it will do it, right? If you run this, and actually you can, through our structured output examples, I actually added a JavaScript example because some of the book is in Python. But you can download this now and try it out, and it'll work. Okay? Now, one other thing I want to note here is that I used email in an XML tag. And if you're familiar with prompting, I highly recommend using delimiters in your prompts because it helps to instruct the large language model of where things exist in your prompt. So in this case, I said email message. It understands that as email. And it knows to look inside those tags as that is the email. That way there's no confusion, right? Because if somebody puts something in the email that sounds kind of like your instructions, all of a sudden it might confuse the prompt, right? And the large language model will give you back a weird response. Okay, so this helps to kind of structure your prompts pretty nicely. And this is the result, right? So I sent those two different emails through the same code, and this is the exact response you get in both cases. And I am close to time, so I'm going to skip all this. I apologize. I was going to go through as well tools and MCP protocol, but I'd be happy to talk about that afterward. But let me talk about context just real quick before I finish, and on context engineering. And this is a quote from Andrej Karpathy, who's an amazing AI researcher. But He says, people associate prompts with short task descriptions you'd give an LLM in your day-to-day use. When in every industrial strength LLM app, context engineering is the delicate art and science of filling the context window with just the right amount of information for the next step. And this, I feel like, is the best quote you should be thinking about when you're building solutions in code that you're calling off to large language models. You need to carefully define your prompts in a way that you're giving it exactly the right information using delimiters, using structured output, with JSON schemas. You need to be carefully defining exactly what you're providing to it to get the best possible response you can, okay? All right, so I appreciate y'all's time, and I'm sorry I wasn't able to go over tools today. I only had 25 minutes, but thank you all for attending, and feel free to check out our book.
started because I have a bit to cover and only 25 minutes to do it. So I'm going to be talking about how to build your first JavaScript AI agent. I have a whole bunch of code snippets I'm probably going to walk you through, so just be aware of that. To give you a little bit of context on what I'm going to be talking about, this is going to be like the really fundamental ways that you can connect your JavaScript code to an LLM, and then I do get into some MCP and tools later on, but that's it. So if you're looking for like deep knowledge on how to do something specific and you've already been building AI agents, this probably isn't going to teach you a whole lot. But what I've found is I've talked to people on the JavaScript Jabber podcast and just people out there in general, is that a lot of people have this feeling that AI agents are tricky, they're complicated, they're hard to put together, and the reality is it's pretty simple. You're making some back and forth with through an API to an LLM, and so I just wanted to walk through how to do it because I think I can do it in 20 minutes and kind of get you all started so that you feel like this is something approachable. So I'm going to dive right in. I'm going to do my personal info at the end. But what we're going to build is a basic chat bot that uses an LLM to formulate responses. If there's time, we'll get into an MCP server that actually connects to Google Calendar and pulls events off of my calendar. And then the technologies I'm using, and I'm just going to walk through why we're using these in the moment. Node.js, I think, is pretty self-explanatory. We're going to use Ollama. Ollama is an engine that you can run on your machine to run LLMs. And the reason I did that was for two reasons. One is I don't want you to feel like you have to go, this is another roadblock that people throw up, go pay for the tokens or whatever that you're using with whatever system. If you want something that looks kind of like Ollama that's out in the cloud, you can use OpenRouter and you can pick and choose your models that way. But if you just want something simple that you can run on your own machine, then I recommend you use Ollama. And then the MCP or model context protocol. And at the end of the day, that's what we're looking for. As well, you also get the privacy benefits if you're running locally, right? You're not doing stuff in the cloud. In fact, my employer is always checking to make sure nobody's using our data when we use these services. So just so you're aware. So yeah, this is basically it. The simple chatbot, I think I've already covered this, but we're going to use the Llama 3.21b model. The latest Llama model is 3.3, but to download it was like 40 gigabytes, and it took a while. My machine's a little bit old, it's a 2019 model, and so it took a while to respond, and so I used a smaller model. So to set up, you just go to ollama.com. I downloaded it for Mac OS and installed it, and I think it just opens up and you just drag it into your applications folder. Really simple. So not much there. And then the setup is basically what you would do to set up any node project, right? So you initialize NPM, you install some libraries. So we grabbed Ollama, we grabbed the MCP SDK. I'm using .env and readline, and then you just run Ollama pull to get your model, and then Ollama start with the ampersand. The ampersand makes it run in the background. So if you want to see it doing its thing, you can just do Ollama start, but then you have to open up another terminal to actually run your application. And then down here, I just created 2 files for our bots, and we're off to the races. So again, this is what these things do. So Ollama, like I said, runs the LLM. You've got your model context protocol SDK, which is the MCP client for your MCP server. .env just gave me some environment variables, which I wound up not really needing. And then readline is, I'm running this on the command line, right? So I'm not even setting up a complicated web interface to run this. I'm not building a React app. I'm not doing anything. It just runs on the command line, and it keeps it really, really simple. So here's where we get into the code, right? So you've got your requires, and then as we get into this, this is just the setup, right? So right here where it says this.olama, it's literally just connecting to the Olama server. This is the default Olama URL, so if you're running it, it runs on that port. The model, you can specify another one in the .env file, but it defaults again to the Llama 3.2. And then I'm keeping track of a conversation history. The last talk, you talked about context, and you can send your conversation history with your requests, and it'll give it better context. And then right here, the rest of this is just processing standard in and standard out so that it can actually collect what you're typing in as a query, and then it can send it back. So this is where the rubber meets the road. So the first thing here, it just gives some instructions, and then it just connects to Olama. Where is it? Right here, this.prompt user, that's where I'm actually collecting read line and handling the prompt. And then I just have a real quick Olama connection check, and it literally just sends a basic prompt to Olama and makes sure that it gets a response. So let's jump in here. So this is get the AI response. It just puts this first message in here. And a lot of the prompt engineering that you'll see, a lot of the interactions you see with LLMs, you'll see something like this where you have a system message up front. So mine just says, you're a helpful bot, right? A lot of times what you'll see is if it does something more involved, right? So when we get to the Google Calendar one, it actually tells it, you do calendar stuff, and you need to respond this way, and you need to do these kinds of things. And so that kind of sets the stage for your interactions with your LLM, and it's rather important to get that right. And you can do some back and forth things with it. And then the rest of it is, this is just sending the message to the LLM and then returning a response. A couple of things that you want to know here. First of all, the model is specified every time you call. So you can have Olama running multiple models, and you can determine which one you want to use. The messages, again, is our message history. And then the temperature, I told you this is really basic stuff. So if you've been doing this for a while, you already know these things. So the temperature is basically how random or flavorful, I guess, your response is going to be, right? And so if you're below 1, the closer you get to 0, the more it's going to consistently give you the same thing with the same wording, right? It gets more creative or more, I don't even know what the right word is, but there's more variability in it if you go above 1 on the temperature. So you can increase that as much as you want, see what you get. I highly recommend that you play with these numbers and see what you're getting and whether you like it. The numPredict number is just the approximate length of the response. And then what we do is, this is the part where it actually captures what the user types in, and then it gets a response from the LLM. So it does check it for the quit message, and then it'll exit. Otherwise, it gets into this, it processes the message, and then it prompts the user again. And so it's a recursive loop. And processing the message, it pushes the message onto the history, and then it gets the AI response, which is on the last slide. And then it puts the response onto the history, and then it logs it back out for the user. So far, so good. Are there any questions so far? So this is essentially, oh, did you have a question?
How high can that tip go? You said you can put whatever you want.
I think you can go as high as you want. I haven't tested that. But yeah, so this is essentially, if you were going to build a chat GPT, I mean, this is basically it, right? And so, as I said, as I was getting started, this is very approachable, very doable, right? If you just want the back and forth with an LLM and you don't need it to do anything else, you have it, right? And what are we talking about here? 50 lines of code? And so don't be intimidated by this. This is pretty approachable stuff. So the next thing that we get into is, okay, well, I want it to do something else, right? I want it to connect to some service, and so in the case of Google Calendar, we'll see in a minute, it can list my calendars, it can list events, it can list, it can create events, it can do other things, right? It can update events. And so for a long time, the way that this was done was through tools. And Ollama does tools. It doesn't quite natively do MCP, but you'll see in the code in a minute that I kind of hacked that together. But yeah, so we have the MCP, the Model Context Protocol, and it's just kind of this standard way of packaging together, hey, this is a collection of things that you can do. And then your MCP server is the part that talks to the AI model and does that work, right? Or I guess it talks to the other endpoint, whatever resource. And then your MCP client talks to your LLM and gathers the information from the resource that you're talking to, in this case Google Calendar, and providing it to the LLM so it can do whatever it needs to do. So how MCP works is, and you'll see this in the code in a minute, but you start up your program and then it starts the MCP server, okay? And so now you've got your MCP server running, and then it requests the tools that the MCP server provides, right? It says, what can you do? And then when it sends the queries to the LLM, it says, hey, here's the prompt that I got from the user, and it says, here are all the tools. Here are all the things I know how to do. And so when the LLM responds, sometimes it's just going to respond with just text, right? And sometimes it's going to respond and it's going to say, call these tools, all right? And so it says, you know how to do these things? I need you to do these things, right? So if I say, what events do I have this week, right? It's actually going to say, well, call the tool, because I don't know. And then it'll call the tool. It may send the information back as another prompt to the LLM, right? So it can format it or do whatever it's going to do. Or sometimes you have something else in your code that formats it. And then it formulates the response, and you're good to go. I don't know why I have that arrow there, because it doesn't, the MCP server doesn't actually do that. So I had to do a little bit of work in order to make Google Calendar work with the MCP server, right? You can't just turn it on and say, you obviously know who I am, right? And so the first thing that I had to do was I had to go to the Google Cloud Console. I don't have a screenshot of that, but I just created some OAuth credentials, right? So that I could sign in and get those credentials. I had to get the MCP server, and that's this MCP server right here. And there's some documentation on how to run that. But it's literally just this command, mpx, and then the name of the MCP server. The authentication, I have a script that I ran. I actually had AI help me write the script, because that wasn't something that I'm super familiar with. And so it does the OAuth flow in the browser. So I ran the script, clicked the link that the script generated, told it I was okay with it talking to the calendar, and then the script did the rest of the work. And so it put the credentials on my computer, and then the MCP server knows how to access those and can talk to Google Calendar. And then the tool discovery, where you just fetch the available calendar tools. So let's get into that a little bit. So one of the things I had to change was the system prompt, right? So before it said, hey, you're friendly. Now it says, you talk to Google Calendar, and so I had to specify if you ask about events or schedule or what's happening, then you've got to use the list events tool, right? And the reason that I put this in was when I initially started building it, it was using the search events tool, and the search events tool was looking for a query where it was saying, you know, it wanted me to be looking for a specific name in the title of the event or things like that, right? It wanted a query string. And if I'm just asking about events or schedule or whatever, you know, what's going on, then I don't have a specific query. I just need to know what's going on. And then the listing available calendars, right? So what calendars can you use? For the rest of it, I had to tell it that time min and time max were in a specific format. I could have given it a string as an example, but I didn't. And then it kept getting confused on the time frame, and I think a lot of that was just down to the fact that I was using the smaller model in Ollama, and so it didn't interpret that quite correctly, and so I was given a little bit of help. And then getting into the MCP, again, what I did is I stored the tools in this calendar tools property on the class. And so then you'll see that the rest of this is all the same, except I tell it that it has the tools when I make the query to the LLM. And then if it comes back and the response message has tool calls on it, then it just executes the tool calls. And that, oh, I have these out of order. So this is where it sets up the MCP server right here. And you can see the command again was npx and then the name of the server, and then I had to tell it where the credentials were and any environment variables I had. And then this is the MCP client that connects, and then this is where it pulls the tools in. So it goes to the MCP client, it says, what do you know how to do, right? And then once it knows, then it had to map it into this tool format because that's what the Llama model expects. If you're using Claude or anything from Anthropic, Anthropic are the ones that came up with MCP, and so if you don't have to do this conversion, it just works. But I was using Ollama because I didn't want to pay fees and because I wanted to run it on my machine, and so this is what I had to do. Essentially, the only difference is that it's not input schema, it's parameters. And it has a JSON format that it follows. And so then, when it gets to call the tools, you can see here it just extracts the name of the tool, the arguments for the tool, and then it just calls MCP call tool, runs the tool, you get a final response, and you're good to go. Any questions? So now you can build a bot, and you can make it do stuff. So at the end of the day, you've got your local AI integration. You can connect to other things. You can call the tools. I didn't show you any error handling. I actually took all that out of the slides because it made them longer and more confusing. But it was just a couple of try-catch loops. It was pretty simple. But yeah, now you can build some AI applications. And so let me open up my terminal here. I don't think that's the right one. Is it going to let me? Oh, there we go. Oh, it full screened it. And now I lost my mouse. There we go. All right. You can see I was playing with this before. Oh, I can maybe see my screen down here. All right, so let me just start this again. All right, so let me run this one first. Can you all see that? Do I need to make it bigger? I can't read it, so I'm going to make it bigger. All right, so this is just the regular bot, right? So it's connected to the LLM. It doesn't have the MCP server on it. What should I get my wife for her birthday? I don't know what that was, but I feel special. So you can see it takes a minute, and then it responds, right? So tell me a little bit more about your wife's passions, right? So anyway, so I can begin to fill her in. And remember, it has the chat history, and so I can continue to talk to it, and that will remain in the context when it makes the request. And so I don't have to remember, okay, what should I get for my wife's birthday? She likes Disney and this and this and this and this, right? And so I can just keep talking to it. She's a big Disney fan. And then, yeah, it's still slow on this machine, but there you go, right? So a Disney Plus subscription, right? Personalized Disney art. Boy, I've bought all these things. So anyway, so you get the idea, right? And then we have our quick command. And then, it's not, okay, so npx run, what was it, bot? No, it was MCP, that's right. So, oh, that's fun. It was working the other day. Well, maybe I won't.
Are you in the right foot?
Yeah, it looks like it. Initially, it was going to do something else, but yeah. So you can see I have a setup mcp.sh. That's what I use to actually connect to Google. I don't. It actually pulls it in and starts it on its own in the code. Anyway, are there any other questions? We're about done with time anyway. All right.
To know offhand, like how big your the previous, how big like the context window is for like Olama, like how long could your conversation history be before it hits like some kind of limit or anything?
I hadn't hit a limit, so I don't know.
You could theoretically just have it summarize and then reset the context size.
Yeah, you can do that.
Right.
All right, well, let me. I guess the last slide is just my information. So I host a JavaScript podcast called JavaScript Jabber. So if you are interested in talking about that, I'm happy to talk to you about that. Yeah, I'm a senior software developer at PrizePicks. And that's it. All right.
Bob Fornell. Talk is on writing testable code. I don't know why I'm looking up there. It's down here in front of me. So, why writing testable code? I'll get to that in a bit. I'm a senior solutions developer with a company called Leading Edge. There. I also have my own business, Code Squid, where I do a lot of mentoring and those kind of things as well. Okay. And let's see where we at here. So, why write testable code? I like the stories. Okay, this is a slide. You can read that. Okay. First company I worked with where I got into dev work, I had a chance to write some amazing code. I started with jQuery, worked my way up to some really fun tools like AngularJS. I saw the start of React and that kind of a thing, but I was also in an organization with a boss who wanted code out the door as fast as possible. And over a 6-year window, I wrote 3 unit tests. Okay. Now, how many have written unit tests at work? How many really understand the value of those unit tests at work? It's okay if you say no. Okay, about half. The hands are like halfway down for those who can't see it. What I saw in that last year that I was there writing code was I was spending about 80%, 85% of my time fixing my code. Fixing the code I'd written over the last 5.5 years. Okay, these small little things. I mean, we weren't talking big stuff. We were talking little tiny, +1 kind of stuff. Really annoying little ones. And I left there. I was getting bored, okay? I like to create things, not tweak things. It's one of the things I learned about myself. And the next organization I was with, I got to write a scripting language, replicating one that was on a mainframe in the browser. I don't know how often you get to write a language. I get to write it. It's really cool. It's a lot of fun. But the first iteration worked. Wasn't exciting, but it worked. And I went to my employers and I said, I need to rework this because I was writing it for a client. And what I had written was not pretty by any stretch of the imagination. And I wasn't proud of it. I wanted to rebuild it, right? They asked me what I needed and I told them how much time it was going to take and they agreed to it. Part of the reason I'm still there, they agreed to give me 2 months to rebuild this thing from the ground up. Rebuilt it from the ground up, 180,000 lines of code, 3,000 unit tests. Okay, the entire remainder of the project had 2,800. Okay, still doesn't mean a lot until you think about the fact that one of the facts you guys don't know is that code went into production, and over the next 2 years that I was at the client, we had 3 reported bugs. Okay, over 180,000 lines of code that was used regularly and heavily. Okay, 2 of those were missed requirements. Not my fault if you tell me a variable length is 12 and it should be 25, right? I mean, it's fixable. But 3 bugs. Okay, to me, it really showed me the value of unit tests, showed me the value of integration tests. Okay, I wasn't dealing much with end-to-end QA level testing and that kind of stuff. Okay, so I talk about here embracing testability, not just catching bugs. What we're talking mostly is fostering that culture of quality, right? Tests are about quality, okay? Key characteristics, modularity, clarity, independence, right? Code has to be organized. And when we say discrete units, I learned that in college. I didn't have a clue what that meant until 25 years later when I got a chance to actually write code professionally, right? It needs to be short enough that you can evaluate what it means. Okay, when I walk into a client and I look at a class in Java that's 6,000 lines long, right? How many in this room are going to understand 6,000 lines? I mean, yeah, if you work there for 10 years, maybe. There's a whole team dedicated to that one project. Okay, can't name the client, sorry. It's not very modular, right? Testing in that case, how do we test that? In that case, we were telling them, as you go to work on those 3 lines that you have to tweak, pull that out into its own class. Eventually, you start to group those together. You test that stuff that you're changing, right? It's small changes. They've now been tweaking that one class for 5 years. I think they're about 60%. That's not bad, right? That's pretty significant improvement for something that would take you 10 years to really understand, right? They have a dedicated team for that. Those folks aren't going anywhere. Clarity. Code is understandable. I think that leans right into that, right? If I can't read that and reason about it easily, how am I going to test it? Okay? And then independence, code and isolation. So what we're talking about here is your code shouldn't be knowing that there's something else out there that has to reach out to and use, right? Those global variables, those parent level variables, and JavaScript is one of the really nice ones that lets you use global variables all over the place, and you can really mess up an application using them, right? So, talk's fun, but let's look at some code, right? We're developers, this is much more fun to look at than a slide that says things should be modular, right? So this is some code that I've written along the way, and actually getKVList is a function that I use. Okay, I've been deep into Cloudflare for the last year, and I'm getting a list from a key vault. Okay, I treat the key vault like a document database. All right, I pass it a host name, I pass it the return original. In this case, do we want the original data as well as the modified data? Okay, and then we have this path that we create, and we have this URL. And this is a general rework of what I did. It's not the exact client code that I use, but it's pretty close. And we wrap it in a promise. Yes, I am using old school, wrap it in a promise. And we have response on data, response on error, response on end. We have an else down there on rejected response with status codes. We'll have a fun story about status codes if we get to it, but we probably won't. And then we have another error rejection down here, and we end. And this is really hard to really figure out what's going on, right? I mean, there's a reason we got rid of promises. Okay, we didn't get rid of them, we wrapped them in a way that they're easier to understand, to reason about, okay? At the same time, I look at this and my first thought is, how in the world am I gonna write a test? Okay, and then my second question is, how am I gonna write enough tests to cover everything that's going on in here, right? We have data getting received, we have error handling, we have end state, which has an if structure inside that. Inside there, we run this extracted with the process KV list. We resolve with a ternary condition inside there. And we have another error out here that we handle, and guess what? There's more code down below. That's a lot of paths through that code with promises in the mix, right? Asynchronous activity. This is kind of ugly. Okay, first refactor I did, just to kind of see if we can clean this up a little bit, is, oh, it scrolled down on me. We have our getKVList here, and now we get the path, we get the options. We have a promise that resolves rejects, and it hands off to the list promise, binding in some variables as it passes it through. I can see that that's a lot easier to test now than what we looked at first. Right? As I look at this next one down here, which is the handle getKVList promise, it's firing off an HTTP request. And it's binding in the request down here, it's passing it on, right? After we've made the request, it's passing the response through to something else. Okay, so this is just handing off a request. Pretty easy to test that, right? We're breaking these chunks down, right? So we're handling that request. Here's where we do our data error end. So now I've got 3 things to test on that. It's a lot in terms of writing unit tests, but it's not horrible. Okay, and then it starts to get a little ugly down here on the on end, but it's really not too bad because it's 2 conditions, although we do have the ternary hiding in the middle of that. And very simple functionality for the URL in the list, but I was starting to simplify because what we want to show you is I started to break it out. Okay, and then after doing the redesign, the refactor, I decided to do a redesign. They gave me a timer, it's not moving. I'm looking at the time, it's like, oh, 25 minutes. I got a lot of time to go, guys. All right, so for those of you that haven't seen async await, now, unfortunately my browser didn't pick up really well and show us the awaits. They're in blue over there right next to the any's. This is a lot easier to read and reason about. And I can see here real quick, I've got a fetch, I've got a response, I got this process KV list that I could mock really easily, I got the return literal that has ternaries, I have a try catch, so I have 2 things to test there. So I've got 4 paths through. Just by shifting this to async await, taking the promises out, hiding the promises, probably a better way to put it, okay? That's a pretty hefty change in how we observe that code and start to think about how do we test that code, okay? So, one of the things you run into in class-based systems is building systems where the constructor does a lot of work. And I'm going to look down here because that is really narrow on my vision up there. So our test setup, okay, we're doing a lot of work in the constructor. Anybody here written Angular? Ooh, more than I expected. Cool, awesome, I love Angular. Okay, and they're starting to get rid of the need for the constructor, which I think is actually kind of cool. I really haven't dug into what that does to my tests. It kind of feels a little awkward, but it hasn't changed them too much yet. However, there is a tendency to do a lot of work up there, right? Fire off some initializer or something like that instead of using the on init. I've done that a few times in the past and gone back and refactored my code, but you can do too much in your initializer, okay? Things to watch for, got a list over there. You can read that, nothing complicated there, right? You've got to look at how hard it is to read and reason about that constructor, okay? If it's not just a couple set of configuration items, okay? Angular we do, for those that haven't done Angular, a couple of things that you'll do in there is you hook into your observables or you hook into your whatever your state layer is, okay? So now we have the signals in there as well. You hook something in there so it knows what to do with those when they change, okay? It's just an initializer, right? If I were telling it to actually start to do more beyond that, then I have to think about shifting things around. Now my examples here, tried to make them easy to reason about, okay? So we have this house class and it has a kitchen that gets newed up, okay? Inside the constructor, we're adding a bedroom, okay? And this is, as you can see by the name of the file, hard to test. Let's see why. Here, we're going to look at some tests. Okay, and yeah, watch my time. All right. So let's look at test. All right, so here, what do? We have to, before each, we have to new up a house. Okay, oh, okay. That seems okay, because what can I do? I could probably mock some things. All I'm doing is I'm newing up that house, right? Why is this hard to test? Do you think? Bedroom is external to this. Kitchen is external to it, right? Mocking that becomes difficult because I have to grab a hold of the already existing, when this file loads, bedroom and kitchen before I can do anything with them, okay? So if we shift into something that's a little more flexible, in this case, I still have the kitchen and bedroom, but I'm passing them into the constructor in a way that I can then assign them. I don't care where they come from, what they are, right? In the previous example, those are predefined values. Somewhere they came into the system, they're global values, right? So here, we've taken the work off of our constructor. There's nothing newed up, okay? So our test becomes much easier to do. We create our mock kitchen or mock bedroom. We new it up, we pass them in, and then we can test things. We can test that they were properly assigned. Okay, since I'm not using TypeScript there, I could have sent any value. It didn't really have to be a newed up class. Okay, oh, we got time, yes. All right, now I'm really behind. Okay, and why did that move? That did move. Okay, so another example of that, we're gonna skip that. All right, now I know I'm behind on time, we're gonna skip forward. Collaborators, all right. Collaborators are objects that, I love this kitchen sink idea, right? Things that do all those extra little odd things that you don't want to deal with right there in that class that don't seem to fit, okay? There are those other things that you have to get a hold of or pass in or pass out. And it's always fun when it's like you have to pass a function in so the function can fire, so the outside one knows, right? Front end, we do that with components all the time. It's really annoying. I don't like it. You're chaining things, right? And the deeper it goes, the worse it gets and the harder it is to manage, okay? And yes, I'm primarily front end. Back end, you guys do this stuff too, I've seen. All right. Here's the sales tax calculator, and we're properly setting up our taxable on there. And then we have this sales tax where we're getting an address, we're getting a subtotal off an invoice, we're doing a calculation in here. Doesn't look horrible, okay? we're returning an amount times taxable get tax rate address, which means we have this get tax rate from somewhere off of tax table, which was passed in. So we know the passed in has a get. We have this get address that was passed in that somehow gives us the subtotal off an invoice. Okay, this is some really weird stuff if I'm just looking at this code going, how do I test it? Right? There's all these kind of like almost imaginary things sitting out there somewhere that I have to deal with. Okay? As I look at this from a test perspective, yeah, I can set some things up. I create this taxable that I can pass in. I'm passing in data, and hopefully I get the right answer at the end with my magic number at the end. I do have another talk I talk about magic numbers. But can we do this simpler? Can we get a tax rate off of our tax table? All right, yes, it's still kind of a magic thing coming in, but the logic to see what I'm doing here, I've moved that calculation back over to this class we're passing through. Okay, makes the logic and testing here significantly easier just by moving things around where they should be in many cases. Instead of doing that calculation in that class, we're doing it in that external one as it comes in. And you can see this test is significantly easier to deal with. Based off that address, our tax rate should be, right? I mean, it's easy to read and understand. Nothing complicated there. And, okay, we skip through the second row. Oh, we got lots of collaborators. Okay, and then brittle state, singletons, okay? So brittle comes with the global states, with singletons, with things that stand out, right? They obscure meaning, all right? Global state will always come back to bite you, okay? I do like this spooky action at a distance, the definition that came through here. You know, when we're running our test suite, our global state mutates from one test and changes in another, right? Has anybody ever run a test suite and everything works fine, and then you go back and you say, ooh, change that so that it runs them out of order, and watched hundreds of failures come through? Yeah. This is where spooky action at distance comes in. Something you've done in a previous test is allowing the next one to pass. Right? Odds are you've changed something outside of that test suite in a way that the next one knows what it should be. And it's, I don't know about you, it's kind of almost horrifying to chase down. I mean, usually I catch this and it's like, okay, we need to stop for a sprint and fix the test, right? And find out where all these are coming from. And it's not always easy to track down. These are scary to find sometimes, okay? Okay, boring, exciting, I don't know. However you want to promote it, I think it's exciting. Spooky action at a distance, okay? It generally only, it says only, and I really don't like the word only, and I probably should take it out of this deck. I've only seen it happen when you're dealing with global state. Okay, are there other ways to have it happen? Have these spooky at a distance happen? Yeah, it's possible. Okay, but your code is no longer, your tests are no longer running isolated. That's where that dependency is coming from, okay? And yes, forces, this is where I cringe, forces developers to read every line of code to understand the potential interactions. I mean, you do. You've got to not only dig through your code to figure out where it might be coming from, you're digging through your test suite code to figure out where it should come from. Every line of code, all right? Lowers productivity, yeah, when you're gonna stop for 2 weeks just to fix tests that should be working, that's a problem. Doesn't mean the original tests were bad tests, but they have dependencies that they shouldn't have, or a dependency that needs reset somewhere along the way, okay? And I do like the last one, confuses new team members, yeah, okay? Doesn't matter how experienced you are, when you see those tests start to fail when they shouldn't fail, it's not a good day, right? So, what are we looking at here? I've got a train schedule, finding the next train, you know, and we're checking to see if the track is closed. Okay, why is that hard to test? Well, I don't know. Well, first of all, we don't have an is closed in here. I'm assuming there's one down there somewhere, right? But it's calling, it's the status checker it's calling. We haven't passed that in, okay? How are we testing this? Well, okay, we got schedules. We're setting up our new train schedules. And somewhere in here we have to do this schedules find next train, and we're expecting it not to be null, right? Yes. Do you have a question? Oh, okay, he's just moving. All right, cool. I'm like, how do we get a question here? In this case, I know a bad response is null, but I'm not checking for a good response, right? I've had to throw that null in once or twice, and I always like, it feels mushy, right? I expect something to be there. I don't know what it is. That should be telling you something's off, right? Just that thought process. So what have we done? We now have an is closed in a checker wrapper, okay? And it's using the track status checker is closed. So we've essentially wrapped that global in this particular case. Why would we wrap the global? It'll still work, right? We're wrapping the global, we're passing it in so we can use it. At the same time, I can mock it for the test. Is this the best way to do it? Maybe, maybe not. Depends on the size of the system. I would assume a company that's doing train schedules, that's pretty hefty software. And I don't want to go changing it too radically, right? Because this is trains, and that's a lot of weight to be moving around, and I really don't want to have trains going bump in the night, right? So can I wrap this track status checker in a way that when I write my tests for this code down here, the train schedules, I can correctly mock it out, okay? I think that's why I picked trains for this, okay? And so in the before each, I'm mocking out my wrapper so that I can test this. Now I did leave the to be null in there, but I probably should change that, right? Okay? Those weird, nebulous, scary outside things that exist in almost every system that's been around for any length of time. So I've got to go really fast because I have 3 minutes. When is global state okay? Okay? When you're referencing some constant, okay? Something that should be immutable, right? In this case, it's a URL. Where are your endpoints, right? That's not a bad one to have a constant somewhere that you reference, all right? But you have to understand that that can't mutate. So in this case, it's a constant, right? I know we do constants in other languages in different ways. This is JavaScript. Shouldn't change, right? We used to use var. Everything could change in JavaScript. It's a scary thing, okay? When it doesn't change, it's much harder to have that mutate and impact your tests, okay? Classes can do too much, and as I have 2 minutes left, we're not gonna talk much about that. Let's see. Large span of, yeah. Classes do too much. They're too big, right? If I go much past 3 screens on a class, I'm starting to think, do I break it down? Now, if my screen is rotated sideways, it's 2 screens, okay? Yes, I've had that question, okay? All right, and it becomes hard to hand off. Get to 6,000 lines, probably should be shot on that one, okay? Takes a lot to fix it, okay? Break them up. You know, good naming conventions. I probably should have to say that before testing. All right, so we've gone over a lot of stuff. One of the thoughts that I had as I was talking to folks and things like that too is one of the things I don't talk about here in writing testable code. You know, I'm a front-end developer, so I do lean into that a little bit. So back-end folks, this isn't gonna help you as much, but if you help the front-end folks, it's useful. Is, you know, writing your code in such a way that other people that are gonna test can handle it too. Back-end folks, it fits for like integration level testing, right? So when they're doing API testing and it's a QA team reaching in, can you put things together in a way that makes their lives a little bit easier? Front end, we're always taught not to use IDs, right? I was taught that, okay? However, what does my QA grab onto? I don't want them to use a class. It's too generic. You're gonna get 50 of them. Which one do they want, right? If I can name those IDs on the row they're on, is it okay to put that in there for testing purposes? I think it's absolutely okay, right? So we need to start thinking about that, not just what we're able to test, but what others are. Now, I believe the right side is my review. Okay, so it's a survey. You can go in, you can review. It's not for the conference. I'm the only one that gets reviewed, so please fill something out there. The left side is, and for those online, I think you get this one too, is my QR code for this slide deck for this. It's the PDF. I was supposed to have turned it in. I'll probably be turning it in here to Danny sometime tonight or tomorrow morning. Supposed to be there a week ago. Sorry, it's not there. So we have, oh, no time left. Sorry, no questions out in the hall. Thanks, guys.
I'm seeing the presentation on my screen and the presenter view on the big one. Let me see 1 second. Yeah, okay. Is that command? No, cancel. How do I do that? Here? Oh, present, okay. Let me play.
There's a button top left at the top left.
Goodness. You know, swapping that, you know, controlling the mouse when it's on the big screen, not that easy. Okay, so it's time. Perfect. So, wow. Welcome everyone. I'm going to be talking about the Gamepad API and how to use the Gamepad API to control joysticks and gamepads that are connected to the browser. This is what we're going to see. I'll check it during this presentation. First, I'm going to introduce myself, then introduce the API, talk about how it works, how can we develop it, and then show some demos. The original idea was for me to code live and do it everything. But yeah, after seeing how CodePen has been working for other people, I decided to just do a presentation. And so let me introduce myself. My name is Álvaro. I'm from Spain, although I live in Austin, Texas. I'm a software developer at General Motors, where I work developing their websites for Buick, Cadillac, etc., for the brands. And I love web development. I do a lot of HTML, a lot of CSS, but today I'm going to talk about JavaScript. And in particular, I'm going to talk about the Gamepad API. So what is the Gamepad API? It's an API, which means that it's an interface. It's a way that JavaScript allows us to handle and manage game controllers connected to the browser. And this is important, not only to the computer, but to the browser in particular. So we're going to be able to read the information from the game controller using JavaScript, and it doesn't matter which browser we're using. And that's the next point. The Gamepad API is supported by 95% of the current browsers. That means that it's going to work on Safari, Firefox, Chrome. You can plug this bad boy to your phone, and it's going to work too. This is important, and you don't need prefixes. If you want to add them for maybe old browsers, you can do it, but you don't need to do it. It's going to work out of the box. And I need to pay attention to the time. So how does it work? I'm going to talk about the functions, the events that are included as part of this API. The first one is the Gamepad connected, that is triggered when you connect the Gamepad to the browser. And another one is Gamepad disconnected, that is triggered when the Gamepad is disconnected. Duh. And that's it. Presentation's over. I told you all the events. Woohoo! Sadly, that's true. Those are the only 2 events that the API has. And now you're going to say, wait, how can that be? And it's because normally, developers, we're used to have like a passive role. Like we talk to the API and say, hey, I'm going to put an event listener there, you know, and I'm going to be doing all the stuff, and if the user clicks there, you run this function. But the API, Gamepad API doesn't work like that. It requires the developer to have a more proactive approach. We need to be reading continuously. We need to be checking the game controller to see if the state has changed. We cannot just say, hey, tell me when this button was pressed. No. We need to be, hey, Gamepad, tell me your buttons, and is it pressed or not? Which is, I find it interesting because it's a different mindset when developing. I have to admit I'm not a gamer, so it's weird that I'm talking about this. But to me, it was shocking because I'm used to just like, oh, when it clicks, do this. But no, in this time, it was the opposite. And also, another thing that we need to take into account is that we need to do it continuously. We cannot just be doing it, oh, I read the Gamepad once, I'm done. No, you need to be checking continuously. And that's one thing that I'm going to go in a second. I'm going to say that a lot in this presentation. So how do we get the gamepads? How do we get, because I said that we are calling continuously for information. So we do it with the navigator get gamepads function. This one is going to return an array with the gamepads that are in the browser. And this is a little bit tricky because it's not the ones that are connected. It's the gamepads. So for example, Firefox and Safari will return a list of the gamepads that are connected, but Chrome will return a list. They don't care if there's nothing connected. They will return a list of 4. And you may find yourself trying to interact with a gamepad that doesn't exist. So we need to be careful with that. And I'm going to show it later in the code. So what is a gamepad? I'm going to explain real quick. ID, somebody may think, oh, it's a unique identifier. No, it's a description. So for example, if I connect this one, it will say something like, oh, it's a knockoff Super Nintendo game controller, USB. Index is the actual unique identifier. Normally is the number, the order in which it was connected to the browser. Connected is if it's connected or not. It may seem like a dot thing, but it's tricky because sometimes this one no, but there's more complex gamepads that they go to sleep. So they may be connected to the browser, but they're sleeping. So connected will return false. So they're connected to the computer, but they are not connected to the browser. And that's a tricky situation. Timestamp is when it was connected. Mapping is something that we're going to see in the next slide. But the idea is that there's a schema that all the gamepads follow for the buttons. So it's something like 0, 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. So if it follows that map as it's defined in the standard, it's a standard gamepad. If not, it's an empty array. We can have the extra reality, XR, and that stuff. I'm not going to talk about that. No time, in 25 minutes. Axis, that's the joystick. So that's an array of double, and I'm going to explain it a little bit because it's fun. Buttons is an array of buttons. And a button is something that is funny because it's another object that can be pressed, touched, and have a value. Press, obvious, if it's press or not press, true or false. Touch, not all the gamepads have this one. For example, you may have your finger, this one doesn't have it, but some controllers, if you have your finger on top of the button, they will notify you. Well, they will not, you will need to read it. So they will mark touch as Boolean. And also some gamepads, they allow to press a little bit down depending on the strength that you press. They will return a value that is normally between 0 and 1. But in this case, it's normally 1, so don't worry about it. Touches, oh no. Touches, that's the next one after buttons. That's a recent one that was added not so long ago. Not so long ago, maybe 2 years, but not so long ago. So there's some controllers that they have like a touchpad. Like I don't know if you have seen the Xbox, the accessibility controller that has some really nice like, so that is what is returning. It's a different object that has the coordinates of where the position of where you're pressing. I'm not going to talk about that. And it returns a vibration actuator. That is a fun thing. That is some controllers, they can vibrate, not this one, because this one is a Super Nintendo knockoff. And the idea is that I said that you can only read, and I lied a little bit, because you can actually say, hey, send a pulse and vibrate. So there's a little bit of things that you can do. Now, I was telling that all the gamepads have to follow this to be considered standard. So 0, 1, 2, 3, 4, 5, 6, 7. If your gamepad doesn't have 16 buttons, it's going to be non-standard automatically. That doesn't mean that it's not following this schema. For example, this gamepad is considered non-standard because it only has 10 buttons. But the buttons follow that schema. That's important. And the tricky part is that there's no way to remap the buttons. You need to do it manually. There have been talk online, and I may have missed something lately, but as recently, you have to do it. If it's not standard, you need to calibrate it with the user, say, hey, click on this button, and you need to map it yourself. In the examples that I'm going to show later, it's already mapped, so it works perfectly fine. And now, how to develop. Now that we have talked a little bit about that, I don't know if, oh yeah, it's big. So this is terrible coding, and I apologize for that in advance. It considers that you're only going to connect one gamepad, but you can connect more than one. As I mentioned, Chrome returns an array of 4, so that's the limit in Chrome. Firefox and Safari, I haven't tested how many you can plug in, but you can plug more than one. And actually, I have plugged 2 because I had a Pong game with my kids playing, and they really liked it, even when it's boring, but anyway, so we can connect, disconnect, and now this is the fun part. As I was mentioning, Chrome returns an array that may have no values. So when we check the gamepad, we need to check that it exists. Because if we don't do that, we're going to do a for each and a null, our code is going to crash, and whatever we're doing is kaput. So really important. You can see the get gamepads there. Another important part is this. As I mentioned, we need to be continuously checking for the gamepad. So people may say, oh, why don't you use set interval or like a set timeout? The problem with those two functions is that they are not really reliable. Like you may say run every 10 milliseconds, but if you are running other operations, they may run after 12 or after 20 or after 9, well, not 9, but 10. And that may be too much or too little, and that's not good because any gamers here? A few. Wow, you should be talking about this, not me. Anyway, so what happens if the sequence, the cadence of the checks is too often, is more often than what it should be? You are running extra operations that you shouldn't be doing. You are making the computer operate more than what it should. What happens if you run this check too late? You get lag. And what is lag? The worst thing that can happen to a gamer. So instead of using set timeout or set interval, we're going to use request animation frame. This function, I don't know if you know it, it's called, like, you know, these screens, they refresh every time, like 60 megahertz is like, I don't know, 60,000 times a second? No, million? I don't know, the math is difficult. I cannot do math at 3 p.m. So every time that the screen is going to refresh is when we check the gamepad. That way, we make sure that we are not running the operations too soon or too late. It's like the Goldilocks, just right, at the right moment. And that's what we want to do. And now we're going to talk a little bit about the buttons. I said it's an array of button objects. As I mentioned, it can change from controller to controller because some controllers have 10, some have 16. But the good thing is that all of them have the same format, and that's important. And it's this format, and it follows this. One important thing to take into account, when you press a button, it's pressed all the time. So this is something that when I started developing this with this, it got me a little bit upset because I click on the button 0, and I was expecting to just run once. I had an event listener, oh, if it's pressed, run this function. And I found myself like I was running, and it's because it's going to be pressed all the time until you release the button. So when you're using the Gamepad API, you need to keep track of the previous value. And for example, only run the function that you want to associate to a button if the previous state was not pressed. Otherwise, you may find that you're rerunning the function when you don't have to. And that's bad, because yeah, if you're running a character and you're using the axe and the joystick, and you press it and you think that it's going to only move one step and it goes out of the screen. You don't want that. So be careful with that. The joystick, It's an array of numbers. This is interesting because the even indexes are the horizontal value, the odd indexes are the vertical, and they are counting from the center, which is really funny. So if you move up, it's going to be minus something, between 0 and 1, sorry, between -1 and 1. And you need to be careful with this because Firefox. So welcome to Firefox that decides that each joystick, instead of having 2 units, vertical and horizontal, is going to have a third one for some reason that nobody knows. That is probably, you know, if you can pull, there's joysticks that you can pull them or push them. So Firefox accounts for that. Chrome and Safari, they don't care. So when you're programming for the Gamepad API and you want to use the joystick, you need to check if the array of axes have 4 or 6 values. Because if it has 6, the second joystick doesn't start in position 2, it starts in position 3. And you can have some issues with that. But yeah, that's just a trick. Well, a trick, something that you would have to suffer like I suffered. And as I was mentioning, the joystick, it counts from the center. -1 would be to the left, 1 to the right, -1 up, 1 down. And another important thing, a joystick is never at 0. So even when at rest, it's going to have a value of 0.001. So if you're checking to move, if the value is greater than 0, move to the right, or move to the left, or do this, you're going to have a problem because it's going to be moving the character all the time. So I recommend that when using the axis, you put a threshold that, for example, if it's more than 0.2, then you perform the action. Otherwise, don't, because you may find yourself with a character that is moving when you are not really touching the joystick, and that's not good. Also, because it's a long number, you can play with it. Like, for example, between 0.2 and 0.7, walk. Between 0.7 and 1, run. So you can play with those values. Don't limit yourself to just doing one action for one thing. Let's go to the next one. So the vibration, again, it's not available in all the gamepads, but it's in the definition, which is good. And normally what you do is that you send the duration of how much it's going to vibrate and the intensity. Different gamepads have different values, and one of the issues is that the definition changes by browser. And again, Firefox. So Firefox came up with their own definition, which is weird, although I think they're keeping up now with the new method that is a lot simpler, by the way. You just say, intensity. Oh, it's intensity. I don't know how to write. Oh wow, I don't even know what that means. So basically, you say a value between 0 and 1, how intense you want the pulse to be, the vibration, and the duration in milliseconds. The old method, again, Firefox, I think, updated to the new method, but still all versions of the browser will use that one. The play effect is messy, is a pain in the neck. So as you can see, there's a lot of things in this API. I just went super fast around it. So my recommendation is, if you're going to use it, you should develop a small library, because otherwise having to keep check of all the values before and after is a pain in the neck. So thank you, and I'm going to show some demos if that's okay with you. I recommend that you use the gamepad and try new things, and I'm going to show you how to create how I create a whack-a-mole game. But you know, you can create it, it's really simple, but just in case, you can make it even simpler. If you remove 5 of the 9, you just keep 4. You give it the same colors at the button, so it's easier to follow. You organize them in a different way, so they're separated. That's good. Then you change the hammer for, you know, something nimble and nice, and you put something to hold it. And all of a sudden, you have a game that made $3 billion 10 years ago. So just saying, don't think that this is silly, like Whack-A-Mole can turn into a $3 billion game. Wow. Anyway, so I have some demos, and I have the links to CodePen, but CodePen fails. So I spent some time earlier running this into my local. So let's start with the connect disconnect. It's a really simple code. One thing that you may notice, I just connected the gamepad and nothing happened. That's because sometimes you need to press a button for it to trigger the connection. It's not always, but it happens. Then you disconnect and it will go away. By the way, it's fun to try if you have an old Dance Dance Revolution mat. My kids love that. They love also the drums with the from the gamepad, sorry, the Rock Band. For the buttons, for example, whoops, I press the blue activates. Press the up, you can see this is all JavaScript. And a funny thing, if you think these are buttons, they're not. This is a joystick. It took me 5 minutes too long to realize that. But yes, it's a fun thing. Anyway, a joystick, here we have a demo with Super Pepe Bros, nothing to do with Nintendo. And you can see how I'm moving. Yeah, I don't know if this one, no it doesn't. Okay, I have another version that you press the button and it says, oh, it's me, Pepe, but not this one. Sorry, I can put it again if you want to. Okay. And now I have an Arcanoid that, again, you can press start and the ball will start, and then you can move it to the right or to the left, and yes, it will go. You press select and it will restart, and I just died, thank you. And finally, this is the fun thing, the Whack-A-Mole, but with the twist for music. Oh no, it's not available. Okay, so the idea is that my kids love when I put this, when I plug they used to see me playing Rock Band and they love that. So I created this game for them, and actually they put My Little Pony songs. That, you know, the thing is that My Little Pony is never going to make it to Rock Band, but they like My Little Pony, and that's what they like. So you can create it, and even without music, it's a pity. But you can see the green button is active. Normally you would have the drums here. They were too bulky, I'm sorry. I should have brought them. So I press the green button and it goes away. Now the yellow, blue, yellow again, yellow again, yellow again.
You're doing so good.
Yeah, man. Anyway, so this is a really easy game to develop. In the links, I have a tutorial on how to do it. I say, oh, how to do it in 10 minutes. 10 minutes. Let's make it 15. But yeah, it's a fun one. So this is the presentation, to be honest. We have 2 minutes. If anybody has questions or anything, please.
Do you set numbers when you do like combinations for fighting games like Z on joystick?
Sorry?
Like for combinations on movement on the joystick for fighting games, like Z pattern?
Uh-huh.
Do you have to set that so it doesn't move just back and then?
Yes, you need to develop that yourself, which is painful. But yeah, especially when you need to do it in JavaScript. By the way, all these demos are HTML and vanilla JavaScript. I don't know if that helps with anything, but it's fun. It's disappointing. So yeah, I don't know why it was working earlier. Oh, it is. It has a music video from YouTube. If you have the YouTube API, you can put it. Another thing that you can do, use AI to analyze a song, so it finds the beat and it marks the colors based on the beat. Instead of me, that I did a version for kids, so it's basically when you click one, it goes to the next one. But you can do something more complex. Any other question? Any other comment? Anything? There.
You said the controller that you had wasn't the same.
Yeah.
The app that you had?
Yeah.
Less buttons. Did you have to map that yourself, or did it just skip over the buttons?
I mapped it myself. I cheated for the presentation. So it should be 0, 1, 2, 3, and this one is 0, 1, 2, 3. So for the presentation, if you look at the code, I will have a comment that is like, I'm sorry, and the remapping done poorly. But yes, you will need to code it. And do you have any question? No.
So this is using basically WebSockets to...
No, this is vanilla JavaScript. It's all running locally on the browser. There's no connection to the internet. There's nothing. The video is using YouTube. Yeah, YouTube. Sorry. Anybody? Oh, there.
Where do you get the controllers?
20 of these, $10 at Amazon. They're terrible. They're terrible. They are all non-standard, but they work. I have my old, and I think it's time's up. So yeah, thank you everybody for attending. I love it.
Started. Here's what I need. I need you to rub your hands together. All right, rub those hands together, and on the count of 3, we're gonna do a giant single clap, called the thunder clap. Y'all ready? 1, 2, 3. That feels good. That feels so good. Listen, friends, I'm so happy to be in the building with you because I think you all came for the same reason, because I'm gonna ask you a question to just get started. Can you feel it? Can you feel it? I can't feel this clicking. Hold on. What's going on in these streets? Okay, can you feel it? Can you feel the energy? In the engineering space right now, in tech, the energy is bananas. There is so much happening. The world is changing rapidly right before our eyes. What a time to be alive. Let me tell you why this is an incredible time to be alive. We have tools that we never dreamed of. How many people have used an LLM today? Now, those same people want you to think about this. Did you ever think that you would have access to something like that? It's like out of a movie. It's like out of a movie that you could talk intelligently and ask a computer to do something almost autonomously. We can build things that we never even thought possible right now. But something's wrong. Something's wrong. Because I'm not sure that we all feel that same excitement that I'm relaying. You're not feeling that same excitement. And I know why. And before I even tell you why, let me tell you that I don't blame you. Because what I'm going to share with you now, it came from here for me. Because I'm going through it too. Okay? It's coming from here. Because we keep hearing stuff like this. Right? I mean, isn't that why when I started talking about LLMs, y'all weren't like, yeah, you were like, ooh. Because people keep saying this nonsense. They keep saying that it's over for you. They keep saying that it's over for me. This job changed my life. I grew up poor on the south side of Chicago. I used to listen to my mother ask people on the phone for $20 so she can get to the end of the month just to feed us. But that keyboard changed everything for me. So when people say stupid stuff like this, I take it personally. That's why I said it's coming from here for me. This whole talk, the whole thing I'm going to tell you now is coming from here because I don't want this to go away, and I'm going to do everything that I can to shape the future. And I want to empower you to do the same thing. Because here's the plot twist: we're not going away. We're not going away. And this isn't just hopeful or wishful thinking. I'm going to tell you a roadmap. I'm going to give you instructions. So the way you can know what you can do to be in the game, to change the game. Now, of course, I can't predict the future. I can only tell you what I think. How does that sound to y'all? If it sounds good, let me hear you say yeah. Yeah. I love that. Why somebody go, yeah? I heard that. I heard that. Because what's happening right now is that the streets, the people, they have lost the plot. They've lost the plot. LLMs and AI they were designed and pitched to all of us as a way to do what? Multiply. Anybody heard that? It was to multiply us. And now they're saying they don't even need us. But I'm going to tell you something that's a hard truth. And somebody on the internet, some leader is going to see this. There's not a single person with something to lose who's talking about developers are going away. The people with nothing to lose, the ones all the way at the top, are the ones saying this nonsense. None of us are saying it. We are looking at the story like, man, what else can I make? And they're talking about how can we make more profits by cutting us. That's whack. Let me tell you the 3 things on the roadmap. Because last year they rushed me off the stage because I was talking too much. So let's keep the story going. Usually I would, but not here. They serious. They got this little green box with the numbers on here. I'm about to unplug it. All right. Here's the roadmap. I'm going to tell you how you should be thinking. All right? What should you be thinking about? How should you be thinking about your career, about the way that you work right now? I'm going to tell you what you should be learning. What should you be focusing your attention on? Because there are so many things out there to learn. What should you be spending your time on? Then I'm going to tell you what you should be building. Okay, what should you be building? What should you be making right now that'll give you the best chances? So how should you be thinking? Now, this is going to be a little bit of a splash of cold water on your face. If you have pearls, be prepared to clutch them based on what I'm going to say next. We got to get over ourselves. I've been working for 20 years. Got my first job in 2006. And everything that I have been doing up until this point was all about how fast and how prolific I could be on that keyboard. How many features could I ship? How many tickets could I close? Seriously. How many hard problems could I come up with an elegant piece of code to solve? That was my primary value for the longest time. But now, we got to get over ourselves. That is no longer your primary value add. I'm not saying those skills are not valuable, but it's not the most valuable thing that you can be doing. I know that's hard to hear. It's hard for me to say because I have been writing code for so long. Just like all of you, I've been writing code for so long. And that is how I have defined myself. It made us special because we could do something that others would look at and be shocked. You ever try to show one of your parents or your siblings something that you've written on the code and how they look at you like you're a brain surgeon? Like, you wrote all these lines? I showed my wife one time. She said, you wrote all of that? I was like, yeah, baby. I wrote all of that, every last line, right? Because that was my value add. But you are just more than that. That is the point that I want you to get. You are just more than that now. See, code isn't our greatest contribution. What you can type on that keyboard is not our greatest contribution. Now it's turning into your ability to communicate and solve problems. Now, I want you to put this in context. Let's put it in context. What are prompts? Because that's how we're starting to interact right now with LLMs primarily, even if it's an agent, if it's on ChatGPT. I hope not, it was Gemini, but I work at Google, so I'm always say that. But whatever interface you're using, what are you doing? You're communicating with it. And what have you noticed so far? Every time you've gotten a poor response, it was because of the poor communication with the model for the most part. Because when you rewrote it and you learn how to prompt better, then you got better outcomes. See, when I get a poor response from an LLM, one of my friends just taught me a new phrase. She said, the call is coming from inside the house. Right? Like it's me, I'm the problem. Because prompts are just instruction. It's information, it's communication. Right? That's all that stuff is. So you being able to communicate and problem solve becomes the way that we solve things now. That's how we build the next wave of applications. I'm thinking about the future of applications. Right now, we're all still doing a few things. We're all still making it happen. That's fine. But what's going to happen next? I like what Aaron said earlier about getting ready before you need to be ready. That's what I'm trying to do with us today. So I want you to start thinking about in your jobs today, how can you add value beyond the code? What else can you do? Now, this is not a shade or a shot at anybody, but I know some of us got into this because we didn't want to talk to nobody. We didn't want to be talking to people. We like being to ourselves, right? And that's okay. But you still have to be able to communicate. Express your ideas clearly. That's what I mean by communicate. I don't mean that you have to come up here with me. I mean that you have to be able to express your ideas, your intents, your users' intents clearly now. Because there is a tool that you have access to that can help you do things that would have taken you months to do, you can do in a week. That is not your enemy. Take control of the narrative. You see, we get to take control of the narrative. It's not your enemy. It's a tool that you have, but it's what you know up here that really matters. So what should you be thinking about? Strategy. How do you impact the strategy at your organizations? You know what needs to happen. You work on the applications. You work on the systems. How can you impact the strategy? Value add. Think about architecture. Now, this is really important because if you understand how LLMs work at the core, they are not magic. They seem magical, but they are spicy autocomplete. It is literally math. It looks at the tokens in a sentence, and it looks at both sides and says, what's the most likely thing that I can put in here that makes the most sense? It is literally the same way that you can hear a song for the first time that you've never heard and guess the next lyric. It is the same thing. You've been trained on that music. That's why they call it training. They train it on data so it can predict. There is nothing novel that comes out of these systems, but you are still the magic. What's that? Teach. Oh, teach. I thought you said something else like, wait, what you mean? All right. All right, think about solutions. I want you to be thinking about solutions. You now have to become a change agent on your team. You're no longer just closing the ticket. That's just the thing. You're no longer closing the ticket. What do your customers need? How do you drive business value? How do you show that the work that you do is going to drive value for the organization? You see, you got to think bigger now. It's harder. This is harder. We have not been taught to do this. This was only told to who? All the technical leads, your VPs, your CTOs, your engineering managers, your staff engineers. They were the ones who were told to do this, and you were the ones who were told to just fix the bugs, right? This is a different way of thinking, but now that we have tools that can fix the bugs, you have to become an orchestrator. Direct those tools. And guess what the thing is? I'm just going to say this. The real special thing that you don't even realize that you know that makes you stand out is even if an LLM can generate the code, you know what's right and what's wrong. You know what the right thing is. You know what the true intent is. We hear all the time about how LLMs get the wrong answer because it's thinking the wrong thing. It think you meant something different. You know. All those skills are still valuable. All right, I got to speed up just a little bit because I'm telling you, don't point at that thing at me. You just quit playing. Now, here's what you should be learning. I ain't gonna lie. You might think you should learn everything, but that's not true. You ain't got to learn everything. Here's what I will learn right now. This is not a 50-year plan. This is for you for right now for the next, I would say 2 years, but I predicted that we'd be here in 3 more years. So the time just keeps shifting. So I'm just telling you, do this for now, and then reassess, and then do what's next. So don't worry about everything. Remember that your fundamental engineering skills are golden. Again, like I just touched on, knowing what's right and what's wrong. I was using Gemini CLI yesterday to work on the demo for today because I was adding an extra feature, living on the edge. Legit living on the edge. Shouldn't have did it. I ain't gonna lie to you, but I was like, I want to impress them. Okay, help me with this. And what it implemented was wrong, but if I didn't know what was right, I couldn't even have spotted it. It's because I knew what was right. I knew what was supposed to happen because my skills are not invalidated by the invention of better tools. Architecture design patterns. Read the Gang of 4 book. Not so that way you can write them by hand, but so that way you can direct the LLMs to do the right thing. So you can influence the architecture. So you can know that if you start to generate a larger module, how should it be laid out? Which patterns should be used? Because just functioning code, guess what we don't have any data on? What happens with vibe-coded applications at scale? We have 0 data on that. Who's going to be around to fix it? But who will even know when it's broken? Okay. Get good at prompting. And, well, I call it spec engineering. This phrase is changing a lot. First it was context engineering, now it's spec engineering, blah, 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 blah. All it really is being really good at deciding a plan that you are describing for what you want. The same way when I go to McDonald's. Why do you go to McDonald's? Because I like it. All right. Because when I make an order, I know how I like my French fries. I like them with no salt. Because that is a trick to get them to give me hot fries. Yes, you can use my trick when you go. But if I do not instruct them clearly that I do not want any salt and that I want light ice in my Diet Coke, what will I get? Something that looks like what I ordered, but not what I wanted. Get good at prompting. Get good at specifying, planning. Get good at planning. You gotta learn, and you also should understand how AI systems work. I can talk with so much confidence about where their strengths are and limitations are because I have been studying. I don't know everything, but I have been learning. I've been spending my time on this, and you should too. If I had to give you two technologies, I know AI technology is changing rapidly. Like literally too fast. It's faster than JavaScript frameworks, right? Like they just keep coming out. But I'll tell you what I think is here to stay for at least a little while. I think MCP, the architecture, the idea is here to stay for a while. I don't know what's going to finally look like, but I think this idea of having contracts that agents can operate with, I don't think that's going away because that gets us closer, or the closest we've been to deterministic behavior, which is what we want from our agentic systems. MCP, learn how to build some agents that can do things. I'll be honest with you, I would learn those two things right now, like literally. Like leaving here today, you're on the plane, like, oh, I'm gonna scroll TikTok. Nope. Like literally, like start understanding those two things. That's what I would do with my time. All right, now this is the fun part. I'm gonna show you some magic. No, well, should you be building new experiences? Because the thing that I'm so surprised by this. Generative AI and LLMs have so much power, so much possibilities for our applications, and the only thing we're focused on right now is code generation. That is so surprising to me. One of the hardest things in programming is dealing with non-deterministic behavior. Meaning you can write as many if statements as you can, but then you get into this really horrible pattern where you just can't program for every use case. You can't program for the unexpected. And now we have a tool that we can embed in our applications that can create the experiences that we never thought we could create. Like right now, I'm not even kidding, right now, you all get your laptops out, you can create an application that can let you try on clothes. Now before the last couple of years, that would have been, I got to learn about what? Computer vision. I got to get some TensorFlow. I got to learn how to pass in camera access, all this stuff. And now you can just do it. You can just do, I mean, that is incredible. So why are we still building the same experiences? It's like you get a fancy drill, you're still building a birdhouse. Where you could be building, accessible homes that like serve people who can't even afford homes. We could be doing so much more, but all we're thinking about is code generation. Build better experiences for your users. Because I'll tell you, here's the three blockers for everything: time, money, and skills. Either you had the time to do it, you couldn't afford to do it, or you know how to do it. LLMs have really mitigated most of these almost to zero. Well, you still need money because you got to be able to pay for those tokens, right? You need some money for those tokens. But now you don't really need the same skills. So here's something I've been thinking about. Like I've always wanted to get into more hardware programming, but I didn't want to learn like assembly or like some of the lower level languages, just didn't want to learn it. But I feel like because I know what to do and I have engineering skills, now I have this very powerful tool at my disposal. I know how to ask the right questions. Maybe I can build some type of like special hardware mechanical thing with a Raspberry Pi. Maybe I can't just do it now. That's something that would take me a long time before, but now it's within my grasp. I want you to think about this, and I really do mean this. Think about building the next generation of experiences for your users and your customers at work. The things that were already too kind of like, your product teams ask you for something. You're like, we can't build that. I need 5 more people to do this. Now you don't, right? I mean, you can do more than you could before, is the whole point. So change the narrative. Like, okay, so let's tackle some harder problems. Let's tackle some harder problems that we weren't thinking about. Let's do some things beyond human scale. See, that's the most interesting thing that every time I talk about AI, that is the thing that I think about the most, beyond human scale. I keep thinking about how we can change medicine. And I'll say it every time, because I'm trying to find the room that I can get in that'll have the person who will pursue this. How can we change medicine through AI? How can we empower doctors? How can we improve outcomes for patients? I always think about my dad. Had we had easier, better technology, could we have found it? If he wasn't one of 150 patients, could have been different. But we're the ones who can change that. I really believe that. We are the ones, we are the builders. We are the creators, we are the smartest people in the room. We can do some really incredible things. Build the next generation of experiences. More lighthearted. Let's go to some code. Well, I won't show you the code. Let me show you my demo. Don't you dare look at my site without complete awe. One thing that I hate to do is go to a website that has a chatbot, and then the chatbot itself can't do anything. It can only answer questions that I did not ask, and then direct me to customer support, which is what I want the first time. What if you could actually build a better experience? Well, I have a store that actually works. You can see the item that I added to the cart. This actually works. So what if I was like, I'm in the mood for, actually, I'm gonna say I have a dairy allergy. Hey, I have a dairy allergy. What non-dairy products do you have? Okay, you could do this with regular imperative programming. You can do that, that's easy. You can't what? Yes, you can. See, and I'm gonna get mad. You see that? Now I'm gonna get mad, because why are you playing on my face during my demo? First off, look up the inventory and then tell me my answer. I can do whatever I want. You hear what I'm saying? First off. Man, so you get too smart. I updated the model. Yesterday, remember I told you I was doing some silly stuff? That's what I get. You know what? Forget it. Fine. Fine. Okay, so what I'm trying to show you in this demo, all right, you see that? Okay, fine. Now, the thing that makes this interesting is that the data for this site does not have any nutritional value on it. It is not tagged in any way. It is just a JSON list of product name, product price, and image. I am leveraging the power of an LLM to ask it questions about the data, but that's still not enough. I'm gonna tell you something. I want to make a smoothie. Make a smoothie. Add the ingredients. If this thing plays in my face. How you spell ingredients? That's why. See, my prompts are bad. Ingredients to my cart. Because I want to do something for me. I want it to have some type of action. Okay. But wait. But look it though, it's actually in there. But here's the magic that I want you to see. And I know this time I'm actually going to let them get me off. But the thing I want you to see is this. This is not magic. I defined tools that I let the AI get access to. Remember I was saying about MCP? This is just a little bit lower abstraction called function calling or tool calling. It's the same idea. But I just implemented this myself. You can add as many of these as you want. But you see how I made my app a little bit smarter? People can still use it regularly, so I'm not like, oh, only go through the chatbot. It's like, okay, you can use the chatbot because maybe you're short on time, or maybe you just want to peruse. You can do what you want. But the idea is that you can build better things. Now, think about taking this to the next level. What if it was a clothing store and you uploaded an image of a pair of shoes you have and said, show me all the products that match? Think about that experience. You see, build the next generation of experiences. All right, friends, let me tell you something. Let me be super clear with you, because this clicker is playing, man, stop it. Okay, here we go. In my humble opinion, let me tell you something. I think this is so misguided, because this is not the race to replace. That's what they're doing. That's what they're talking about. Don't let them. Remind people about remind your leaders about how your quality of work improves with the new tools, but how you are still the most important part. A 200-mile-per-hour race car is only as good as the driver. Come on. This is a chance to enhance, friends. Enhance your skills, enhance your output, enhance your capabilities. You're still the magic. Because I'm going to tell you something. We have been working, you put your hand down. We have been working nonstop on building artificial intelligence. I'm going to remind you something about yourself. You're already intelligent. Thank you. Scan this code for slides. You scan this, you get my slides. You can get the code demo that I showed. Please rate the talk and leave feedback so they can ask me to come back again. I appreciate y'all. Thank you so much.
All right. Hi, everyone. Thank you, guys. I appreciate everyone rallying. It's pretty late in the second day, so thank you for being here. So my name's Mike, and my talk is called Evidence Over Advice, Learning Programming Faster Using the Scientific Method. And I just want to apologize. I have a little bit of a cough. I've been battling it all conference, so if I need to stop and take a drink, I'm just going to do that. So, okay, so I have had this thought many times in the course of my professional career, probably hundreds of times. I wonder if that's actually true. And as developers, we're constantly bombarded by all kinds of information from blog posts, from YouTube videos, PR comments, our mentors, just like lots of different ideas and information, some of it conflicting. It's hard to know sometimes like what to trust, right? And so, some people deal with this by kind of like eroding that feeling of just, just trust what the experts say, right? I want to propose a better way of doing it. So this is a feeling that I pay attention to a lot, and it can, this feeling of skepticism. And I kind of want to propose like a mental model and like a framework for how to actually act on that and how to actually turn this skepticism into knowledge, right? Something that you can actually see and like experience for yourself. And the way to do that is using experimentation. And that's through the scientific method. So spoiler alert, scientific method. So I'll get to that. But first, I want to tell you a little bit about myself. I'm Mike, staff software engineer at Rippling. I've been doing this for about 15 years. I currently live in Seattle with my wife and my 2 kids. I like music. I play guitar and piano, and I sing. I like video games, and I do close-up card magic. So if anyone wants to see some card tricks out in the hall after this, feel free to come hit me up. Okay, back to the talk. So this is a situation I found myself in just last month, where this is an actual screenshot of a code review. And this is React, by the way. I'm going to try to keep the React talk like a little bit minimized, but I can't help myself a little bit. There's a lot of confusion with React. So this is React. This teammate is proposing using useMemo on this column config declaration to basically not render a new array every time the React component renders, even if it's not required. And so I'll take a quick detour to talk about what useMemo does. So what is useMemo? It's a React hook that lets you cache the result of a calculation between renders. And so React renders a lot. Like every component renders a lot, like hundreds of times, maybe thousands of times over the course of an application's lifetime. And when these renders can be expensive, they can be cheap. Usually a render is pretty cheap, but sometimes you can do something expensive in the course of a render, and you don't necessarily want to do that every single time. So sorting a big array, doing something computationally expensive, right? Like doing some math, right? So React uses this hook called useMemo to basically record the result of that calculation, and so the next time it can just reuse that result. That's what memoization does, and that's what useMemo is. So just a quick diagram. We have some inputs. It goes into useMemo, and then we test whether the inputs have changed. If they have not, then we use the cache result. Otherwise, we recompute the result and we update the cache. So kind of going back to this example, this is not a very expensive operation. He's proposing that we cache this result using useMemo. It's just an array declarations, and array declarations are cheap. And so I was just sitting there thinking, like, what are we even doing here? Like, why, what is the point of this comment? And now this person has to go and update their code and trigger another 2-hour build to get this useMemo in, but it's probably not even helping performance, right? And so there's been this debate ever since useMemo was created. And over there on the left, you see the React docs, where you should use useMemo as a performance optimization. And on the right, you have kind of thought leaders like Ken C. Dodds and Josh Comeau saying, don't overuse useMemo. It's a performance optimization. You should use it judiciously. Ken C. Dodds has a really good quote where performance optimizations are not free. They always come with a cost, but do not always come with a benefit. And I'll caveat this, like React doesn't say use memo everywhere. There are some people who clearly have taken that message and said, we should use memo everywhere, right? And so React docs explicitly even say like, when should you use memo? They talk about using it judiciously, but some people have interpreted use memo as we should be using it everywhere where we could conceivably get any kind of performance benefit. And so what do you do with this information, right? I think it's like pretty safe to trust Kent and Josh. They know their stuff, but I kind of want to propose like a different method. So the real question is not even about use memo. It's not about even performance, but it's about intuition, right? So how do we develop an intuition about performance? Not just, again, I don't want to over-index on the use memo thing, but I will use an example. But just zooming out, like how do we develop our intuition about programming? So let's go back to high school. So this is, everyone has probably learned this in their biology class. The scientific method, the cornerstone of human knowledge in the past several centuries. Ask a question, gather information, form a hypothesis, run an experiment, analyze the data, and draw a conclusion, right? That's the scientific method. It is how we empirically develop our knowledge based on observation, not just by trusting thought leaders or thinking our way into theory and coming up with answers that way. You can kind of tangibly see the results of reality. And so I've kind of distilled this down into 4 steps. Predict, what do I think will happen? Run, execute the experiment. Result, what actually happened, and takeaways, what did I learn? And so I will talk a little bit about each of these steps, and I'll show you some examples a little bit later. I want to talk a little bit about why I think this method is so effective too. So in addition to kind of arming you with a lot of confidence in the way that you engage with other people about your knowledge, again, I think the argument is a lot weaker when you say, hey, some X thought leader said we should do this, versus I tested this, right? I tested this and I can see that we should do this, right? So that's one benefit, but I think the even bigger benefit is that we learn a lot better when we are actively learning, right? And so, on the left we have someone reading blog posts, someone watching YouTube videos, right? They're passively learning, they're kind of engaging with the content maybe a little bit more than surface level by taking notes, but it's still pretty passive. Versus, that kind of knowledge I think is easily lost. And versus actively kind of thinking through what kind of experiment would prove this, right? And sitting down and writing code. And then at the very end, looking at the result, right? And tangibly seeing the result and gaining knowledge that way. And so I really think that this has played a huge role in my ability to retain information throughout the years. So, I know what, I think a common objection is oh man, I have to experiment with everything I learned. No, I don't think so. I think we're all busy people, you have a job to do. And so I've kind of developed these triggers as to when it makes sense to experiment. So the first one, and it's 3 C's. The first one is controversy. If you start to see different thought leaders disagreeing on certain things, I think that's a good time to kind of test things for yourself. Confusion, weird bugs that make no sense, I have kind of examples of each of these, and I'll show you what those look like. And then curiosity to see if new tech lives up to the new hype. And the underlying thread to all these, I think, is they resist Googling, right? So controversy, if you Google it, you're going to see the different results from different people. You're not going to really know what to believe. Confusion is sometimes you don't even know what question to ask, right? If you're super confused about something. And curiosity, if it's brand new, then there might not even be anyone writing about that yet, and you might be the first one, right? So if you go out and do that experimentation yourself. Cool. Any questions? I'm going to get into the demos. Cool. All right. So demo number 1 is around controversy. When do you use memo? So I have kind of this is a very, very bare bones way of measuring performance. If you look at this slide, basically starting at the top, you got this number of iterations, so you usually have to set this to a pretty high number, at least in the thousands, tens of thousands, sometimes millions, in order to see the result, like an appreciable difference, right? If you're testing sorting 1,000 items in an array, that's going to take like nanoseconds, right? So you have to kind of do that over the course of like many, many iterations in order to see a difference between the memoization version and the non-memoization version, right? So, so testing without the memoization, you know, like this is like non-React land. I have another slide for React land. So basically we have this like start without, and that basically starts a stopwatch, and then you run this expensive operation X number of times, you stop the stopwatch, right, and you record that time. Then you have the cache version where you start the stopwatch, and then if you've cached it already, you don't run that operation again, then you start the stopwatch, and then at the bottom you compare the two, right? Very, very simple method of like doing some benchmarking. And so, you know, like I think this is like probably like the absolute simplest way that you could do some benchmarking to see the performance impact of an optimization. And so there's a little bit of creativity involved in the React version because what we're testing is renders, right? And how long it takes to do some rendering. And so what I have here is this parent component that has a count variable, and we pass the count variable into a child. And so every time you increment the count variable, the child will re-render, right? And so in that sense, you can kind of test the clock time that it takes to re-render a component 10,000 times, right? And so we have this child without memoization, and then this child with memoization. And so in the with memoization version, we're obviously using useMemo. Any questions about that? I know I kind of ran through that quickly. Cool. All right. So I'll just do a live demo real quick. And so I've kind of created these test harnesses. Can everyone see the text okay? Okay. Cool. So I have these different ways. Oh my God, where are all the borders? That's fine. Okay, so I have these 6 different scenarios, right, where we kind of like test different operations that you can do within a useMemo version and a non-useMemo version, right? So this one is just a math problem, right? This one is a person object creation problem, right? Sorry, not a problem. It's like creating an array with a bunch of properties, right? This one is sorting an array. This one is sorting a bigger array, right? This one is doing like a chain filter and like map and like something that you'd kind of expect to do in like a real app if you're doing some array manipulation. This last one is calculating the Fibonacci number. Like this is just like a, you know, you don't need to know too many details about what, if you do lead code, you know what Fibonacci is, but like if you don't know what it is, it's just something very computationally expensive. You do some recursive calls to calculate a number, and the higher up you go, like it gets really, really expensive to do. Sometimes it takes like multiple seconds, even if like math problems usually don't take that long. So I'm gonna just run through all these tests, and you'll see the results. Cool. All right, so you can see that so first of all, like I was surprised that useMemo wins in every circumstance. I thought that there would be some circumstances where useMemo is slower, just based on like what Kent C. Dodds and Josh Como were saying. I will caveat that like this doesn't test memory. Memory is like much harder to benchmark, so I couldn't get that done in time for this conference. But you can see that like there are cases where the difference is almost zero, right? It's like very close to zero. There's some cases like this large array sort where the difference is like very substantial, right? So 90% reduction in how long sorting this array 10,000 times takes. Same thing for calculating the Fibonacci number, right? So all that's to say, like, and so, you know, kind of going down to these like trivial things, I'm not trying to like just twist the data to my own narrative, but this is really like trivial if you consider the fact that like you're dividing each iteration by 10,000 times, right? And so if the difference is like 50 milliseconds, you divide that 10,000 times, you're like talking nanoseconds, right? And so that is like never gonna make any kind of difference in any kind of like real performance impact, right? But it might make a difference in terms of memory, right? And it also makes a difference in terms of like readability of your code, complexity. And so my conclusion from this is that there are definitely situations where use memo doesn't make sense, right? And this object creation, like going back to the original PR, is one of them. I don't think that it makes a big enough difference in that case. So, so this is my summary of my conclusions. I predicted that use memo would be faster in heavy computations, slower in light. The result was that use memo was faster in all cases, but it was negligible in some of them. And my takeaway is that Kent and Josh were right. You shouldn't use it all the time. Demo number 2, confusion. So this is an actual story from my career. Like, these are all actual stories from my career. I was doing something like this. AKA what the F is a microtest. So the case of the missing spinner. So I was doing something like this in React, and again, I apologize for anyone who doesn't use React. But the demo will actually take place in Node, but I'm just setting the stage in React because this is how I discovered this thing. So I was setting loading to true, and I was using the loading state to display a spinner, and then I would run a task and then set loading to false. It's pretty cookie cutter stuff that everyone's done at some point, right? So I would expect to see the spinner while the task is being performed, and that was not happening, right? And so I'll go to this spinner demo. So we have 2 versions of this. Promise chain, right? Where I click the button, and there's supposed to be a spinner down here, and there is no spinner. And then I click on here, this set timeout version has a spinner. So when we basically refactored, like I was just testing and I refactored the perform task to use a set timeout instead of a promise, I would see the spinner. What's going on here, right? This is something that, like, again, resist Googling. I wasn't really sure how to Google this. And so I was basically running an experiment in Node and trying to see, like, what is the result of something like this, right? And so quiz time. I'm curious if anyone knows the answer to this. What will this output? What order will these console.logs output? So option number 1, sync promise set timeout. Option number 2, sync set timeout promise. Option number 3, set timeout promise sync. I'm gonna, number 1, who thinks it's number 1? Right, show of hands. Number 2, sync set timeout promise. And number 3, set timeouts promise sync. Cool, a lot of no hands, I respect it. Like, yeah, I mean, like, I would have no idea if I didn't run this experiment myself. All right, so I'm gonna go and okay, so here is the script that I wrote for this. Again, this is exactly what you just saw on the slide. I'm gonna run this, and we'll see what the result is. Sync, promise, set timeout. So good job to everyone who voted 1. So yeah, that is pretty confusing. It was pretty confusing when I was, like, looking at this. And sorry, I'm trying to find the slideshow again. Where is it? Okay. So yeah, then you can go even deeper, right? You can kind of, like, run these in a loop and interleave them. And so I'm gonna just jump to the conclusion real quick that promises always run before set timeouts. So promises are running, like this experiment helped me, like, realize that, and then, like, do a little bit more Googling. I found, like, a Jake Archibald article about microtasks, and promises always run before set timeouts. And so you have to kind of be mindful of when you're using these things to avoid things like UI freezing, React rendering, jank, all kinds of, like, other issues. And I'll just show you what this looks like. So, the call stack, you have the call stack, and then after that, any microtasks that are queued, these are promises and a newer function called queue microtask. And then after that, it's set timeout, set interval, and then only after that is, like, request animation frame and paint. And so, yeah, this is something I learned from experimenting, and I got to see with my own eyes, and I can do the deeper dive as well. Where basically I have these functions running, like, interleaved in a loop, and you can see that they always get grouped up. So next tick, always, all the next ticks run, all the promises run, all the set immediates run, and then all the set timeouts run. So this was a pretty surprising result that I had. Cool. All right. And demo number 3, curiosity. So I have been in the field long enough that I was here before web workers were a thing. Web workers are a thing now. But I remember when they were first coming out, I was like, oh, this is really cool. And I like did a little experiment with them to kind of figure out. And like obviously these aren't the original experiments I designed, but I kind of recreated them for the purpose of this talk. But so this is the experiment I designed. This is like without web workers. There's Fibonacci number again. Did kind of like the stopwatch thing where we start the stopwatch and then we calculate Fibonacci, the 40-second Fibonacci number, and then we stop the stopwatch. Then we have with web workers, web workers, for those who aren't familiar, lets you offload any work from the main thread to a background task, right? So the main thread of JavaScript is like everything that's required to interact with the browser, right? That's like like if something's running in the main thread and conflicting, then you can't do things like highlight text. You can't do things like click buttons, right? The browser is, for all intents and purposes, completely locked up, right? And so web workers let you offload that work. So if you have some CPU intensive tasks, like calculating the Fibonacci number, but more realistically, real tasks like image processing or like parsing like a huge CSV, right? Those are like real tasks that like could run in the CPU in the main thread and block everything. But this allows you to kind of offload that work. And so I wanted to basically see what that would look like if I offloaded that work. And so with web workers, this is what it looks like. You basically send a message to your worker to say, I want to process the 47-second Fibonacci number 10,000 times, right? Or 100,000 times. I don't remember how many times I did it in that experiment. But this is the main idea. The web worker runs in a background thread. It takes the number, it calculates it, the 40-second number a bunch of times, and then it sends it back to the main thread where you can kind of see the result. And so I'll show you what the live demo looks like. So this is a worker demo. So I'm going to show you, this is a 40-second Fibonacci. I think it takes like 4 seconds. And while I'm clicking on it, right, notice that my cursor is stuck in like your browser is like completely useless when it's running on the main thread, right? I'm like trying to highlight text, blah, blah, blah. I can't do anything. And then in the web worker version, you click on this and you see the spinner. Like, oh, by the way, this is what it's supposed to look like. It's supposed to have the spinner. It's supposed to, like this elapsed number is supposed to change. But in the non-web worker version, nothing's happening, right? So web workers are like amazing for offloading this. And now I know because I've seen it with my own eyes that they're really good for this kind of thing. So my prediction, web workers help performance perception by offloading work from the main thread. They do exactly what they promised. They do increase the complexity, so you shouldn't use them all the time, but you should consider them for heavy computation tasks like image processing. So I kind of went on this whirlwind tour, and you might be like, wow, those are really random ideas, Mike. Like, why did you, what is the point of all that? Like, I actually intentionally made them kind of like all over the map, because my goal is not to teach you about web workers. My goal is not to teach you about use memo. My goal is to kind of encourage you to have the experimental mindset, right? So like, these are all the different types of use cases that you could do some experiments for. But I just want to encourage you to basically think like, what could I run my own experiments for? And to help me kind of cement my knowledge. And so I kind of want you to go from passively consuming to actively participating in your own knowledge growth. And so I've devised a couple of starter experiments, right? Like, can you test the performance impact of for each versus for of? Or inner HTML versus like creating 10,000 elements using inner HTML versus create element, or concatenating stuff using templating strings, or concatenation. And I just want to be clear, like, do not go and get in an argument with your teammates about this stuff. Like, all the performance impacts of this are going to be like completely negligible. This is just like encourage you to like think through like, oh, this is like just to get in the habit of doing some experimentation for yourself and seeing the results for yourself. And that is it. Happy experimenting. Thank you for your time. I have time for like one question, if anyone has it, but otherwise I can just see you out in the hallway. Elder.
So one of the good things about the scientific method and what have you is the ability to kind of replicate things that you discover. So have you been into a situation where
So the question was, have I ever run in a situation where I've run into additional confusion from, is that right?
Or even be a conflict on something very similar.
Oh, interesting.
The method is, as you discover things, if you pretty much prove your hypothesis, you may encounter things out of your scope, and it's only you have to retrofit.
Yeah, yeah. I mean, I would say that like this use memo thing was an example of it. Like it didn't conflict with like a previous experiment I'd done. But in my head, I've carried like, oh, the idea that memoization should lead to performance impacts, right? Or performance benefits, right? And so, you know, that is something that I've kind of like retrofitted my own understanding for and like kind of brought that back to yeah. Like it's usually, I think like a lot of times when I'm doing these like controversy experiments, I'm often correcting a misunderstanding that I've had before.
Did you start a flame board afterwards?
I did post the results of my experiment in the thread, but I still got overruled. They were fine. Like it's fine. Like they you know, sometimes it's like the case where the team just needs to like keep the style consistent and stuff like that. So you know, get it. Yeah. Yeah. Cool. Thank you so much.
today. So probably this is the last session of the day 2. I see low presentation, but that's fine. People tired. Yeah, my name is Arfi Siddiq. I'm a fellow of information from privacy from IAPP, which is International Association of Privacy Professionals. So I work for Synchry.ai as a solution architect. And today I'm here to talk about designing secure, compliant, and scalable test data pipelines for enterprise DevOps. So we'll be talking about in the coming 20-25 minutes, I'll be talking about what is the test data crisis, an enterprise test data framework, and how those security implementations in the part of the enterprise test data management, and how we do the DevOps integration and the case studies in it. And we all know that the test data is very critical for any software development that we do, any product that you do it. And what is the crisis for the test data management? And so we all know that in the traditional development, people copy the data from production to non-prod and start using it. And that causes, right now, it's a crisis from the regulatory compliances that we have, like GDPR, CCPA, HIPAA, and PCA. These mandates the limit of the data, as well as if something happens to the data breaches, those are all very costly. And so that we have to, when you use the test data in a lower environment, we have to make sure that you obey the these compliance laws in it. And then the other crises are a challenge for the test data is the technology complexity. Right now, everything is a microservice based, and then you need to have a test data for testing your APIs, testing your the application testing, and all. You need different varieties of the data. And at the same time, it's a multi-cloud deployment. So you are deploying the products in multi-cloud. So you need different varieties of the test data, even for a QA one set of data, for UAT one set of data. So all these, the technology complexity and the regulation pressures are making sure that you have to practice a better or efficient test data management. And on the top of this, velocity of the demands means how frequent these releases are happening. Right now, in the 2 weeks of sprint, you need you need to prepare well ahead, that 1 week before that you should prepare the test data, so that the test engineer have enough time to take it and test it. And then you should have a mechanism to get this data in a multiple environments as well, because a lot of people using in a different use cases, like as I mentioned, API testing and the application testing. And this crisis, if you see that based on the reports from IBM Security Cost and the Gartner reports, the cost of the poor test data management is, as part of this, if you get a fines, it's around 3.5 million for a data breach happens. And at the same time, if you have a poor quality of the test data, there are 43% of the delays happen to the projects. And then if you see that developers or QA people, annually they spend, each person spends 280 hours of their time to just prepare the data. And because there is no way that they can, if you don't have a test data management in place, they are just building this test data by writing some SQLs, by using some files and all, and then there is no way that they can maintain the data. For every release, they have to modify it and do it. So that's where it's too expensive with respect to the time. And then the product defects, the actual product defects are 68% are due to the bad data and bad test data, not having enough data. So all these mandates to have an efficient test data management, and that's where what an enterprise test data management should contain is in a way to automate the data provisioning. So you just have an automate mechanism to read the data from production and copy into the non-prod environment. And then on the top of it, as we have limitations with the regulations, you need to have an advanced masking rules on the fly, in transit, or in place, that you use format preserving encryption, tokenization, dynamic data masking to mask the data. And then sometimes you always, there is no way that you can get a data from production. Sometimes it's a new product that you are building, there is no data in the production. You need to have a mechanism to synthetically generate the data. So your effective TDM should have a synthetic data generation, and then the life cycle management of the test data means you are provisioning the data. You should have a provisioning of these data into a version control and the self-service portal, like you just single click, you provision the data, and then you maintain different versions of the data. Each version goes to a different teams can consume it. And then after the testing, you should have a mechanism to auto clean it, and then apply some different retention policies to just to get rid of that data once the data is in after use. And then how you can secure these data test data models, and you can use a RBAC role-based access control and the attribute-based access control. In the RBAC, as I mentioned in the test data, we have a self-service portal, and when the self-service portal is there, you can control it to a role-based access. And so you can have different environment specific like dev, QA, staging, and then have different roles created. People can access based on their roles, and then it's a time specific, time bound access as well. So you can just provision them access to particular time, or these role based you can access to your identity providers as well. Like you can use SSO single sign-ons to use that data. And the other one is attribute-based control access, wherein you can classify the data like it's a confidential, restricted data, and then based on the classification you can assign it. And then based on your location where you are testing it and your network as well, you can define it, and then you can assign those data, test data for the user. And then your test data management should have a containerization of test environment, wherein this is very important that once you provision it, you should have a container, like you create different versions of the data, you can take the snapshot of the data. It's a kind of virtualization. You take the virtualization of data, and then that isolates the data from production to a non-production environments, and wherein the same set of data you are taking the snapshot or virtualization, and then with a single click you are resetting the data back to different environment, wherein you can maintain the consistency of the data and the scalability. You can just use this data in n number of environments across different releases, different teams, and everywhere. And then automatic destruction of this test data after the use. So containerization is very important when you go for a test data management. And then you integrate these test data pipelines or whatever the data provisioning that you are doing, you are masking it, and you are generating a synthetic data. All these should be integrated with your CI/CD pipeline. So that's where in the current software development, that's where people are integrating everything from the code deployment to all the test data provisioning. And so in this, you build first step is to build all these test data requirement in a version control environment, and then you apply specific subset and masking rules and then you start provisioning these automated masking subset operation, and then test execution, wherein these data containers attached to your test environments, and then test specific data mutation tracked and version. And post test cleanup, once the data is provisioned, there should be an automated refresh of the data and the cleaning of the data. And these are some advanced data masking techniques that as per the regulations what we discussed. One is the format preserve encryption, wherein if you see the SSN always follow a format like 3-digit, -2-digit, 4-digit, and then after the format preserve encryption will maintain the same format. So this is very important for some of the application because they go by different formats, and you should not change the format. And then tokenization. Tokenization is similar to the format preserve, but wherein you can just you don't need to maintain the format here, wherein the important here is the referential integrity to maintain this after the tokenization. And then differential privacy, wherein you add some noise to the data, like here in the salary is 105750, wherein after masking you can add some range to it so that the salary will not change much. And then data variance is the age. Here is a 42, wherein we change it to 39. It's okay for the masking wise, but sometimes the age is, when you mask the age, it will impact the policies on the application side. For example, in the insurance, if your age is going, if you mask the 42 age to 52, maybe those benefits it will have an impact to the benefit. So make sure the date range should be fallen into the, it should not break your core functionality of the validation in it. And then beyond these masking rules and data provision, this is a synthetic data generation beyond masking. As I mentioned, every time we don't have a test data to be provisioned from the production end. Sometimes it's a new product that you are building new functionality which is not yet there any data in the prod. So you need to have a mechanism to synthetically generate this data. And traditionally we use some randomization to generate some random data like for names, for phone numbers, emails, for the testing purpose. But now these ML techniques we have, it can learn from the existing data and replicate how much data you wanted based on the complex patterns that you provide to the ML engine. And so that maintains a complex relation between the entities, and it generates the realistic edge cases of data, and then scale to a millions of billions of synthetic data that you can generate in it. And the case study set. So this is as with my experience from Informatica, prior to Security, I was with Informatica for 10 years. So Informatica has a similar product kind like of test data management, and then there are other tools in the market which contains all these properties are there, because there is no product that contains all this data masking, synthetic data generation and the containerization together. But there are products in the market who are very strong in the containerization. Some products are strong in data masking, some products are strong in data subset, and there are few products who are very unique to synthetic data generation as well. But when I started implementing this globally across Fortune 500 companies, so there are a global bank where we implemented, they are facing a lot of challenges with the test data, wherein they have to comply with all these regulations as well. So, but we centralized, we implemented a self-service capabilities of test data, where the team can go at the single click, they can connect to a number of databases like on-prem databases to cloud databases and the mainframe databases. They can get the data from production, and on the fly they mask it, and wherever required they synthetically generate the data as well. And then these jobs are integrated with the CI/CD pipeline, and in this SDLC lifecycle, whenever they are deploying the code, they are deploying the code with the test data as well along with the code in it. And that way they are now very compliant, that they improved their compliance improvement by 92%, and it saved a lot of time in the data provisioning, and wherein it's a 74% data reduction. Before this, every engineer was spending time on creating their own test data, and so there is no collaboration and all that. And the cost reduction as well, because we are using containerization, we are not using the physical servers to have the cost going on that, right? So it's a reduce on the physical server investments as well. Yeah, the key takeaways here is we need an efficient test data management, wherein, as I discussed, we need to have a pipeline integration with the containerization and the version controlling of it. Then we need to have a compliance automation by including dynamic and persistent data masking rules, and the synthetic first approach. And so wherever this production data is not there, we can go for a synthetic data. And yeah, that's all for now. And yeah, this is my email ID, and oh, it's gone in again. Sorry for that. Yeah. Yeah. Any questions? Thank you. So any questions? I don't have anything to demo because these are all commercial products that I cannot demo, but this is just a concept that I want to brief or share my experience that people can use it. Yeah. Yeah, that's it. Thank you so much. Thank you. Thanks a lot.